Okay. On behalf of the Russell Sage Foundation, the Sloan Foundation, and Princeton University, welcome back to Nerd Camp. The Summer Institute in Computational Social Science. So today we're beginning into a more substantive part of the program, and today we're going to talk about collecting digital trace data. And before I say a little bit more about how we've come to think about digital trace data here at SICSS, I'm just going to go over the schedule for today's program. So first I'll say a little bit about what digital trace data is. Then I'll have a lot to say about the strengths and weaknesses of digital trace data. A lot of the people participating in SICSS this year come from either a data science or a social science background, and I think a focus on the strengths and weaknesses helps us anticipate some of the common objections that, say, a reviewer might give you to a piece in our field. Issues around representativeness, issues around algorithmic confounding, drift, and so on. Next, we'll begin to talk about actual techniques. We're going to learn screen scraping in R, and then we'll have a brief coffee break. We'll come back, we'll use application programming interfaces. We're going to collect data from Twitter, and we'll use some of that in tomorrow's exercises. And then finally, we'll have a discussion of what I consider to be the cutting edge of the field, and that is building apps and bots for social science research. And I'll talk about some popular recent studies and also share some concrete tips for building apps in both RStudio's Shiny platform as well as Google's Flutter platform. Okay, so getting right into it. What is digital trace data? So when we did our citation analysis of the field that I shared with you yesterday, you probably saw a lot of work by economists, computer scientists, and psychologists and sociologists, but you didn't see many physicists in there, which is funny because a person who could be credited with kind of founding our field, or at least partially contributing to the founding of our field, is Duncan Watts. And Duncan Watts wrote this about 8 years ago. He wrote, "Just as the invention of the telescope revolutionized the study of the heavens, so too by rendering the unmeasurable measurable, the technological revolution in mobile, web, and internet communications has the potential to revolutionize our understanding of ourselves and how we interact." 300 years after Alexander Pope argued that the proper study of mankind should lie in not the heavens but in ourselves, we have finally found our telescope. Let the revolution begin. Inspiring words, 8 years ago, I think, we were a little more excited about the revolution part than the reviewer part, but we've come, I think, to all agree that there's enormous potential in new types of data, both to answer old questions that were once thought to be unanswerable, but also a new genre of questions about new digital spaces. And so when we talk about digital trace data here at SICSS, we usually don't just refer to one of the more popular forms, which is social media data, so data that come from, say, Facebook, WeChat, Twitter, LinkedIn, and so on. Also web search data, a really interesting source of data that's being more broadly employed. Also advertising data from social media platforms that allows us to look at user behavior, little digital footprints of human behavior. Once upon a time, there were these things called blogs. Sometimes we study them. But it's important to note that the kind of digital revolution is not linked specifically to the internet. There's many new forms of data that have resulted from, for example, the digitization of administrative data or historical texts in archives. Many of you may know the Internet Archive or the Wayback Machine or the Common Crawl. These are all efforts to archive most of the internet, which really enables a lot of really interesting research. And if we're going to be hyperbolic about it, we could call it time travel, right? Going back and really being able to see the world as it was, at least online, and that's a big caveat, some years ago. And finally, digital trace data, I think, increasingly has come to encompass audio-visual data. So as we're watching, remarkable advances in image processing and machine learning, we're really able to pull out new features from audio-visual data also NLP, which we're going to talk about tomorrow, which really move the needle. So what's new about these data? This is a picture that used to impress people. Now it's not so impressive anymore. This is Michael Macy's research. Michael Macy is a sociologist at Cornell who leads a lab that did some of the pioneering research in our field. And this is telecommunications data from Britain. More or less every phone call that was made in Britain for, I believe, a month. And here you're looking at the data actually mapping the country, right? Pretty unprecedented at the time. This came out around 2011. Similarly, many of us got really excited when we saw this map from Facebook. These are renderings of Facebook friendships across continents and across countries. This is made by a Facebook data scientist in, I think, 2012. And on the one hand, it's amazing that simple data points illuminate entire continents. On the other hand, it's quite obvious that certain continents are invisible. So you'll note the relative absence of Facebook users in Africa and in Asia and in parts of South Asia. And now that we've kind of begun to enter the hype cycle that Matt was talking about yesterday, where we once had peak expectations, and we were talking about doing crazy things like getting rid of theory because we have so much data. Now, much of our work is trying to figure out how to take advantage of the good things that come with digital trace data and get rid of the bad things. The reason we need to do that and develop hybrid approaches is manifold, but one of the main reasons is what Matt was talking about yesterday when he made a distinction between custom-made and ready-made data. So as you'll recall, Matt was saying that very often in conventional social science research, we create custom-made data. That means that we have a research idea from on high, we operationalize it, we do our own survey, we try as best as possible to do some kind of representative sampling, we try to control the conditions of an experiment, prevent interference, and so on and so forth, and we try to estimate a very neat causal effect. And in contrast, if that's like the Michelangelo of social science, if you'll remember from the analogy from bit by bit, the counterpart is the urinal, right? The ready-made data, something that is being repurposed for something else. And because I really can't stand this analogy, I prefer the Picasso. But the idea here, right, is that the data that we want to use to, say, track the spread of epidemics or understand social inequality or patterns of crime or the diffusion of ideas really weren't built for us. They were built by corporations to help people connect with each other or to enable commerce. And so a lot of what we need to do as we approach these data is think about kind of what we can take that's good and what we can jettison that's bad. So I'm going to move now into the second section of these slides today, the strengths and weaknesses of digital trace data. So we're a positive group. Let's begin with the positives. This one really used to impress people, less so now. The data are big, right? There's a lot of data, and the rapid increase in data co-occurs alongside the remarkable increase in computing power. Yeah. So in 2012 alone, there's more data collected than all previous years of human history combined, according to some estimates. And back in 2012, that was really exciting people. Now it's a mixed bag. Maybe you've begun to play with large data sets. You realize they require different types of stewardship and wrangling and pose simple logistical challenges. And maybe you realize that if you have some kind of imperfect data, having a lot of it isn't necessarily a panacea. And so the fact that it's big is great. We can aspire to do, even in some cases, population level analysis, which really turns fundamentals of sampling on its head. Although the opportunities to do genuine population level analysis seem to be slipping away, and I'll have more to say about that in a few minutes. A second kind of key positive about digital trace data is that it's always on. So here we have the example of Tahrir Square and the various social media platforms that were used in the uprisings that were part of the Arab Spring in Egypt. And the idea here is, if we follow the conventional social science model, we have to kind of anticipate the things in the world that we want to study. We have to go out and design a careful study. We have to we have to observe some social phenomenon and develop some hypothesis, and then go out and design a study to test it. On the other hand, many of the things we are most interested in studying as social scientists are things that are more or less unpredictable. Things like collective revolts or revolutions or other more spontaneous or emergent phenomenon, especially at the group level, where we really need not only data that is naturally occurring, if you will, but also data that is kind of embedded in real social relationships. So a key feature of digital trace data is that it's always on. We can very often look at old problems from a new lens. Now, of course, there's going to be many caveats about this as well, and I'll have more to say about Tahrir Square and social media for the study of revolutions in just a moment. A third kind of key feature and something that's been celebrated by people in the field is that digital trace data are very often non-reactive. So what does that mean? We can collect data points or digital footprints, as you might call them, that describe some type of socially undesirable behavior. So here we're looking at some data from the data scientist Stephen Abramowitz, who's written a very popular book that looks at how Google search data reveal that everybody lies, meaning that most people are Googling things that are socially undesirable, often to large and surprising degree. And there's these kind of neat kind of toy examples. We have other examples of various kinds of health behaviors. I've done some work using Google search data to track searches for pro-ISIS related content, for example, and have been able to begin to look at the pre-radicalization stage of internet radicalization using some of these data. But again, they come with huge caveats about not knowing who's doing the searching very often, or at best, having aggregate measures of who's producing the data. Often these data are also very opaque insofar as the way that they're created by social media platforms is not very well specified, especially Google. A fourth kind of key feature of digital trace data is that they capture social relationships. So, one thing, if any of you are familiar with network analysis, or if you've ever read a study that has some kind of network data collection component, one of the most vexing things to do as a social scientist is to try to figure out how to measure and observe a social relationship. So you may be familiar with something like a name generator, where you might ask a survey respondent to name the 3 to 5 people who they would go to talk to about important matters or something like that. Turns out most people name one person. There's kind of all sorts of biases in terms of who that person names. And even more importantly, we're still left with like small little snapshots and slices of the network rather than the global picture that would enable us to test hypotheses about the topography of the network, meaning issues of where information might spread, or how social inequality might develop in a network, that we really need to test the cutting edge of our theories. And so when digital trace data first came online, many people were very excited about capturing social relationships. And of course, this is one of the ubiquitous network plots of Twitter data. This here is from the European Parliament, fascinating organization that it is. And we now see many of these kind of all over the place, and I think the kind of golden age of the Twitter network plot is dying, meaning that now reviewers and wise social scientists know that the people behind these relationships aren't necessarily best friends. They may scarcely know each other. We know very little about the qualitative dimensions of these relationships, and so again, a feature of this data could also be a bug. And so a lot of the work we're going to talk about today tries to develop hybrid strategies to take advantage of some of these good things and get rid of some of these bad things. So a recent example from my work is we ran a large study, a large field experiment, and we were linking Twitter data to survey data. And we discovered in one of the early stages of data cleaning that we could use the network data to look at the issue of causal interference. So if you're running an experiment, you have to make an assumption that observations are independently and identically distributed. This is something we all learned very, very early on in graduate school. And if someone in the treatment condition has some kind of connection to someone in the control condition and begins to act differently, and that treatment spills over into the control condition, we have a big problem. When we go to subtract the difference between the two, there's no observable difference, and then we wind up with bad inference. And so one way that social media data can kind of be a bug and a feature here is when you can link Twitter data to survey data, you can actually observe many of those social relationships. Maybe not the deep, intimate relationships you would want to observe if you really wanted to know who's connected to who, though we did have one married couple in our sample. You can at least begin to identify where you might be making violations of your experimental design. So these are the good things. It's big, it's always on, it's non-reactive, and digital trace data capture social relationships. On to the weaknesses. There are many. So first one, and this is a relatively straightforward one, is that digital trace data are often incomplete. So if you want to say, go study something like incivility or harassment on the internet, and years ago you could visit Facebook fan pages and fairly easily obtain data on user behavior, users interacting with each other around, let's say, a political post. And you might make a call to an API, which is a tool we're going to talk about later that allows you to extract large amounts make custom data requests from online repositories of data. You might get some kind of data points that describe how many people commented on a post, and you might then want to develop some metric of incivility around this particular issue based upon the number of positive or negative comments or something like that. But very often it's the case that comments get removed. Or that digital trace data, despite having the appearance of being a hygienic measurement and an unperturbed measurement of human behavior, often have an incomplete nature, either because of some other type of human behavior or just because of simple data transfer issues or what's known as pagination in the API world, which we'll talk about a little later. So in other words, one of the reasons we think these data are good is because we very often think they're complete or could possibly represent a population, but when we go to use them, sometimes they're incomplete, and sometimes even worse, the incompleteness is invisible. Second, this is one we began to talk about last night. For those of you who saw Alondra Nelson's talk on ongoing attempts to promote collaboration between academics and industry, we're seeing sudden shifts in the public availability of data from social media platforms. So Facebook has been in the public eye a lot, and if we look at over time kind of how their privacy settings have changed, we've moved from a world where much of the data on Facebook, certainly not all of it, not private user networks, but at least public interactions around fan pages and to some extent groups, and even people's comments on pages that they might not have known were observable by data scientists or folks like us, could be easily collected. And now we've reached a moment, most recently last year, where we've seen a broad kind of retreat of data availability. This has happened for a number of reasons, partly probably any number of significant scandals involving data access. We've spoken already about Cambridge Analytica, but there are many others. And to some extent, Facebook as a leader in the industry, I think inspires fear in its competitors when people see the potential for things to go awry. So this is a big challenge. If you want to get Facebook data these days, you're either going to have some kind of collaboration with Facebook, you're going to have to build some type of app that gets data from users with their consent, or you can, scrape a very small number of very public pages that are probably of pretty limited utility for studying a lot of important issues or the issues that might interest any of the couple hundred people who are at SICSS this year. So hopefully many of us are working on that. Social Science 1 that we heard about last night from Alondra Nelson is an exciting initiative, but also Twitter and other industry partners have begun to discuss other models of sharing data. And we have, at the Summer Institute over the last 2 years, had a variety of relationships with industry partners from Facebook, Twitter, Microsoft, and elsewhere. And we are hoping to continue to build those relationships. And it's possible that in future years, as we go forward, we can explore collective mechanisms to access data via this very group. So in the short term, it's a big downside. But in the long term, I think we'll find that many of the most important questions are going to be very complex questions that demand what Dr. Nelson last night called the army, right? The army to solve them. So if we're the army, we need to have access to the data, and we're working on that. This is perhaps the most well-known weakness of digital trace data. They are non-representative. So here's some older data from Pew. I think this is from about 2013, 2014. And what we're looking at is just demographics for a variety of different social media platforms: Facebook, LinkedIn, Twitter, Instagram, and also the broader adult internet using population. And what we see here is, at least at that time, Facebook pretty well approximated the internet population in the US, whereas Twitter skewed much more towards ethnic and racial minority groups, also at that time skewed more towards people in urban spaces as opposed to those in rural spaces, people with slightly higher incomes, people who are slightly more educated, and people who very slight bias towards liberal users at that time. And then, of course, as we look at things like Instagram, we see various other demographic shifts. What we're not seeing here is age. And the thought experiment I always love to give to students is, how many of you are on Facebook? And most people raise their hands. And how many of you are on Instagram? And most people raise their hands. And then I begin to ask them, so where do you spend most of their time? They say Instagram, they say Snapchat, whatever. Not Snapchat so much anymore, but Instagram, right? And then, when you ask them, why don't we use Facebook? They tell you, well, my parents are on Facebook, right? And my parents are watching what I do. So what we're seeing is there are not only demographic biases, but these demographic shifts themselves create shifts in human behavior. So if we now use Facebook to study, say, some type of illicit behavior, we're on the wrong platform, right? And so these are all dynamics that we have to be really sensitive to. And I think reviewers in the social science world, and increasingly in the kind of interdisciplinary field more broadly, are really acutely aware of this. So if we are using Twitter to study something like the Tahrir Square uprisings in Egypt, who's actually doing that tweeting, right? Is it elites? Is it young people, right? Turns out when we did the kind of post-mortem of Twitter's role in the Arab Spring, we learned that many of those tweets were coming from London, right? And we're recounting things as they were happening, as they were being viewed on TV. And many somewhat now silly-seeming early papers were making claims about various properties of Twitter discourse actually influencing the trajectory of the revolution, when in fact what we were seeing is people kind of narrating the revolution, right? So we need to be really sensitive to these things, and unfortunately it's really hard to get really high-quality data on the representativeness of different platforms. There are some workarounds. I'll talk about using Facebook Insights data in a little bit. Others have used Facebook advertising data, Google Analytics data, and there's various efforts afoot to create large panels that describe in much more detail what types of social media sites people are using, when, where, and why, and also efforts to link those surveys to social media panels to get perhaps a much more complete picture of what's going on. So, digital trace data are non-representative. Then there's this issue of drift. Right? This is where I show my age. I was a proud MySpace user many years ago. I'm seeing some nodding heads, but not too many, which does make me feel old. Okay, so once upon a time, let me tell you kids, there was this social media platform called MySpace, and it was all the rage, right? It was the social media platform, I promise. This is where my undergrads are like, what planet are you from? MySpace really for a moment seemed to be poised to take over the kind of social media landscape, if not Friendster, right? And why am I bringing up MySpace and Friendster? It's because these things drift. So, even if we might want Facebook to be the kind of way that we can take the pulse of America by, say, sampling some random distribution of comments about a topic, if we're seeing things like massive shifts of young people onto Instagram, which of course Facebook owns, but nevertheless, if we're using Facebook to study these shifts, we're going to wind up with a really distorted picture of what's going on. So people are coming on and off platforms. Platforms themselves are merging, they're dying, they're changing, they're adapting, and all these things are very difficult to model. And so, what many of our early studies of internet behavior, for example, could simply be picking up the early stages of internet behavior. Maybe we were acting in a way that's very bizarre and things will level out in years to come and we won't know. This kind of drift of on and off digital platforms, but really this is an issue that goes back, in any kind of digital data source. If we were talking about administrative data collected by governments, when did the government start developing the funding to collect the data? When did their data collection effort shift online? What changed when it did? We want our observations to be neat and independent and standardized, but very often they're not in the digital world. Another particularly vexing issue, and for me maybe the most vexing issue about working with digital trace data, is that they can be algorithmically confounded. So this is a nice paper by David Lazar, Gary King, and a co-author called The Parable of the Google Flu. Show of hands, who's seen Google Flu here, heard about Google Flu? So most people, not everyone, have heard of Google Flu. And back in 2011, the Google Flu was celebrated as one of the big success stories of computational social science. What happened? Well, Google data scientists discovered that they could track things, searches, especially Google searches, for symptoms of the flu. And when they did this, they could create very fine-grained estimates for where influenza was spreading. And they began to do this with such accuracy that it tracked the Center for Disease Control's, that's the official US body that tracks the spread of influenza. They began to track the CDC estimates really well. So up here, you're seeing Google in blue and the CDC, in orange, and the CDC in blue. And you see this like pretty remarkable tracking. And this is a point where people, particularly zealous people were saying things like, well, maybe we don't need to do influenza surveys anymore. Maybe we can use Google Flu. And then on one day in late 2012, the Google estimates nearly doubled the CDC estimates. As you might imagine, there was a lot of anxiety. What's going on? Are we experiencing a new bird flu, a new pandemic, a new burst in influenza? And turns out no. Turns out what created this spike was not some underlying shift in the spread of disease. This was a day when Google implemented a new type of advertising feature in which people who searched for symptoms of the common cold were then delivered advertisements that asked them questions like, do you have the flu, or recommended flu remedies. This then prompted those same people to search for, do I have the flu, which was then mistakenly interpreted as evidence that the flu was spreading, right? So the key idea here with algorithmic confounding is that some underlying shift in the platform can change user behavior, which then becomes reinterpreted as human behavior when it's really the result of some type of algorithmic confounding. And what's particularly concerning is, sometimes we know about these shifts. We've been able to do a kind of a postmortem of the Google Flu in this nice paper that appeared in Science a few years ago. And we were able to understand more or less what happened. We still don't know the exact details. But more concerning to me are the various ways algorithmic confounding might be happening that we just have no way of knowing about. In some cases, these could be shifts that are industry secrets. In other cases, they could be the algorithms responding in ways that even the people who built the algorithms don't understand. So we've all now heard about examples of people being served ads on Facebook that are, somehow extreme or objectionable or otherwise wrong, right? And when we begin to abstract up to the ways that machine learning has come to recast so many people's experience of the internet, this is a big problem that we simply don't have a great solution for yet. Finally, I mentioned earlier that digital trace data kind of have the allure or maybe the appearance of being neat and digital. You hear the word digital, you think, oh, it's going to be a neat spreadsheet. Right? I'm going to get a nice, neat CSV, run my regression model, call it a day. As we'll see today, most of the time when we extract digital trace data, either from screen scraping or from an application programming interface or from some other means, we get really, really messy data that might come in a variety of formats that are unfamiliar for many social scientists, things like JSON or XML data. And even worse, they will involve data structures that are uncommon in social science, like lists. Lists are arrays that can contain multiple types of elements. These are very common data structures on the internet and in many social media companies and in many of the archives that house administrative data. But they are not well understood and not easily parsed or cleaned and restructured into the neat rectangular square data sets that many folks need or want to run some type of linear model or some other type of model. So a lot of the frustration of working with digital trace data for many people who have never done it before is just simply learning to both extract the data and clean the data, even after accepting all of the other limitations that I just mentioned. We began to talk about this weakness yesterday when we talked about ethics. These data are really sensitive. This is a newspaper article, or I think it's a Vox article, about something that happened on Twitter about 3 years ago. So one day I woke up, I logged into Twitter, I saw a post that had already been shared or retweeted 30 times, and it was I believe it was a Danish researcher who had scraped 70,000 OkCupid profiles and had quite audaciously linked the data and just spread it out onto Twitter. And many of us quickly kind of swarmed on this individual and said, please don't do this, please don't do this. There's any number of reasons why you shouldn't do this. The people who produce these data don't know that you could do this. The data can be linked in ways that would be an even more extreme invasion of privacy. And perhaps most importantly, you're ruining it for the rest of us, right? There are many of us who are pursuing these data with careful IRB regulation and with utmost care and really going beyond IRB standards, as we emphasized yesterday. And we're still seeing this, this type of kind of disturbing violation. And in this case, I think part of the issue is that the particular researcher wasn't under oversight by an institutional review board. And of course, we have to worry about the broader public too. As we release our tools and our data, we have to think about these kind of adversarial attacks that Matt began to talk about yesterday when we talk about these kind of sensitive data. So we both need to be worried about data getting out, but there's also logistical challenges related to handling these data. For example, a recent paper by David Lazar and co-authors shows that it's really easy to re-identify people with 3 or 4 points of metadata. And so when we begin to link these data, which is what we all want to do, we all want to link administrative data to survey data or social media data to survey data, what we begin to find is that it can become very trivial to identify individual respondents to a survey, given 3, 4, or 5 data points. And this is certainly something that I've struggled with myself in my own research, linking especially Twitter data to survey data. The unknown unknowns around re-identification in the future make it really hard to follow another principle which we hold very dearly here, which is open science and transparency. And so sensitive data create kind of a twin challenge of handling it, being sensitive to the people who reproduce it, taking the user's perspective, as Matt encouraged us all to do yesterday, but also in this secondary and very important task of sharing the data. So if folks are interested in the Q&A, you can share some techniques we've developed in our lab to share the data in a way that we think strikes a balance between the privacy of the respondents and the public need for reproducible science. Another key weakness of digital trace data is a weakness of many different types of data that are naturally occurring, and that is that only certain types of people write certain types of things down, right? So you might call this elite bias if we're thinking about history, right? History is written by the elites, and if we're doing some analysis of historical archives, we always have to be mindful of this, and historians spend a lot of their careers trying to recreate what it was like to be an ordinary person at a particular point in time in one country's history, right? So we still have that problem from all these old texts, and we also have it from newer texts. That is to say that the people who are tweeting may have some type of unobservable characteristic. Right? They might be wealthier, they might be more educated, or they might be exactly the opposite. The problem is we really don't know. We know that only certain types of people are on certain types of platforms, but we don't know exactly who shares what and why in a really systematic way. And some of the best estimates I've seen suggest that the majority of people on, say, a social media platform are lurkers. They log in, they read, they might like something every once in a while, but they very rarely post. And they're mostly there to read about the posts of the small minority of people who generate a lot of posts, right? And so even if we can be content that something like our recent study of Twitter showed that Twitter users, we were able to show that our data were vaguely representative of the US population, but when we began to peer in and see who was actually tweeting, we noticed all sorts of biases in who's producing tweets. So something we have to be mindful of if we make the assumption that something like a social media post or an administrative record or a medical record or doctor's notes or nurse's notes, these are not things that are just consistent, independent observations of human behavior. These are things that are produced by humans. So we have this type of inherent bias. We also have the old-fashioned kind of file drawer problem. People don't tend to share the results of unsuccessful research. We've all heard this problem, hopefully by now in graduate school or afterwards. And this scaled up to a broader level should make us mindful not only of the tendency for elites to produce the data, but also for most people to only produce certain types of data. So we could talk about publication bias if we were doing some kind of citation study, but more broadly, and for much of the human behavior we might care about, we should probably be more concerned about things like positivity bias. So the tendency for people on Facebook to only share good information about themselves. Your Facebook posts make you seem really interesting, but remember, dear, there are people who know you in real life. Right, we've all kind of experienced this, very rarely do you see the post like, I just lost my job and got divorced, right? You see the marriages, you see the kids, you see the, depending on your age, you see, the celebrations. So, and we could talk about whether Twitter has the opposite bias, but suffice it to say that the types of behavior we're seeing on different platforms are a feature of the platform. And though much of my research is highly quantitative and uses cutting edge methods from machine learning and other fields, and we'll talk about some of those tomorrow, I've recently done a large study of a couple hundred Americans and did longitudinal in-depth qualitative interviews with them in order to kind of peer into the ways that people are actually using social media. And I don't have any research to share from that. I'm still writing it up right now, but I can share with you some kind of very general preliminary insights, which is that the way that we're assuming people use social media is just profoundly wrong. We hear things about how people won't say certain things on Facebook because of family members, but then will say them on Twitter, but don't somehow realize that Twitter is a much more public forum that could, for example, bring unwanted attention from an employer. So people just have very basic lack of understanding about the differences across social media platforms, let alone how their behavior could shape other people's behavior or how we might study it. So these are all pretty daunting problems. We've gone through about 7 or 8 of them now, and we could have a really good conversation about whether the positives outweigh the negatives. But at this point in the field, I think it's fair to say now that we'll see fewer and fewer papers that only publish with digital trace data. that don't somehow acknowledge one or hopefully all of these biases, even though some of them might be really hard to address, like algorithmic confounding. And so I think it really takes us back to the hype cycle, which Matt lectured about yesterday. We're really beginning to see the transition from what you might call the trough of despair. So if the Google flu predicting the CDC estimates with remarkable accuracy was maybe created the peak of inflated expectations, and like these data could do no wrong. They could increase organ donation. They could increase voting. They could improve the spread of happiness and stem the spread of depression. They could what can't they do, right? They can spread revolution. They can spread democracy. And then the trough of despair is like, okay, well, maybe not, right? We've now have all these reasons to be skeptical that the data are going to be some kind of silver bullet or a single paradigmatic shift that will transform all of our data. We're never going to get rid of the tried and true conventional forms of data collection. And what we really need to do to get out of the trough of despair, which I think despair is a strong word. I don't think we're quite despairing, but we are, I think there's a little bit of anxiety. And so the question is, how do we get to the plateau of productivity? And so for the next few parts of the lectures this morning, we'll talk about getting the data. We're going to set aside and kind of bracket a lot of these really deeply important questions. I'll bring them back in and explain some ways of possibly mitigating some of these biases or weaknesses of digital trace data as you collect them, or at least understand what they are. But we're going to spend our last section today on possible solutions, looking again at developing apps for social science research and building bots for social science research. So we've got about 3 minutes for questions. Are there any questions in the room or comments? Yeah, Kevin.
In terms of representativeness of users of different platforms, this is a really difficult problem, I think, and I think we really need to start thinking about, should we just look at who's using them, or should we weight it by how often they're using them?
Yeah.
So, yeah.
That's a really great comment. I'm just going to repeat it for people on the live stream. Kevin Munger's comment is we shouldn't simply count the number of people on the platform, but we should count how active they are on the platform. I think it's a really sharp insight. Yeah, we could potentially develop weights or something like that, like probability weights. Yeah.
So you mentioned that some of your current research that you're writing up about how people who aren't on social media, how you're studying the method that you used, which was longitudinally, qualitatively interviewing them. Can you talk a little bit more about some of the, did you consider other methods? Are there other methods out there for looking at what people are?
So in this particular study, we collected both longitudinal survey data, longitudinal qualitative interviews, and then linked all these to the Twitter data. So we have this interesting opportunity to compare the qualitative responses to the quantitative responses to the Twitter responses. And that has already illuminated some really surprising findings. So for example, the trolls are like the nicest people you'll ever meet in the interview, just like night and day. And we're doing a lot of work with good old-fashioned sociology to try to explain some of that. But another really intriguing finding is that people who are changing their minds, and we did a study which exposed people to opposing political views and expected, what we found in an earlier study, which is a strong backfire effect. And we did see the backfire effect in the quantitative data, but what we did not see is a orthogonal shift in the qualitative data. So people are telling the same stories, even though they're answering quantitative surveys the same way. And so this also raises some really interesting puzzles about what people say versus what they do, and illustrates another reason why we can't just take social media data at face value for me.
Were they face-to-face interviews?
No, yeah, they were over the phone, unfortunately, yeah. And that would be another interesting level, right? I mean, maybe the troll is, I don't know, even nicer. I just want to make sure, are there any questions from the live stream?
Yeah,
okay. Yeah, let me take one from the live stream and then I'll come back to Jay.
All right. So this one says, if big data, such as Twitter, is non-representative, how can we use it in an academic publication? Can you talk about how you or others have framed a research question using big data? Also, if big data doesn't have metadata, like Twitter, I believe, how do we detect non-representativeness in our data?
So the question is about what do you do when you have non-representative data and you'd like to publish this data because you'd like to one day get a job. It's a very good question and one that you should all be thinking about. And I don't think I have a single kind of cure-all solution, but one thing I would say is a lot of the papers, I've been an editor for many years, and a lot of the papers that I've seen get negative responses kind of come out charging at the old findings and say, I have this new data, and my data are bigger, and my data capture social relationships, and my data are longitudinal and natural occurring, and your old survey of 1,200 people doesn't do all those things, so everything you said was wrong, everything I said was right. You can imagine, if you take the reviewer's perspective for a moment, what kind of response that will elicit, right? It will respond to a defensive mechanism where the focus will be on why your data is wrong and why you're underappreciating the kind of values and virtues of the old ways, right? So one thing is to, and this is good advice for any publishing, show some respect towards the people who came before you, and instead of, just claiming that you've fixed all the problems, maybe, raise some new questions rather than, definitively, answering like questions which we all agree are, extremely complex. So that's one solution if your paper is about reapproaching an old problem with new data. But there is another genre of question which I think is very important and one can also get a lot of weight out of in journal publishing, which is to ask new questions about new digital spaces. And there, it's a much different style of argumentation rather than trying to juxtapose what you're doing with what's been done, which often forces you into the situation where you have to know things about the representative posts that are maybe unknowable. You can then say, look, this is a new social space. The spread of misinformation on social media or what have you, or online harassment or something like that, that needs to be understood with these new spaces. I recognize, and even there, you of course need to be sensitive to the fact that these aren't capturing all the human relationships, but you can give your readers or your reviewers the thought experiment of, is it possible to study X without these new data? So if you're talking about something like, what I study, political polarization, the thought experiment I often give people is, could you imagine studying that without social media? Once upon a time, of course, but now it's a much different picture. And so there, the style of argumentation is, here's a new shiny thing that I want you to appreciate with me, instead of, I'm breaking down your castle with my Twitter data. Yeah. Let me take Jared's question and then come back.
You mentioned having strategies for sharing data while also to protect privacy while also enhancing reproducibility. Sure.
Yeah, sure. So the first thing is, I would say don't share full text data. I think that's a kind of pretty, now that's vexing because many people want to revisit the text data in some way. Some people will say you could share a bag of words, which is a data representation, for those of you who don't know, where you count the appearance of words or sequences of words that then allows you to do some forms of automated text analysis that might allow you to pull out features. But even there, I personally would worry about identification, even after, say, removing sensitive terms. And even though we have new tools in NLP or natural language processing, like named entity recognition, that might allow us to try to systematically pull out named entities or sensitive proper nouns or something like that, these are not perfect and very unreliable. And if you're trying to scale to say, like in our study, we have, I think, 2.6 million tweets or something like that linked during the study period, I'm not going to read all those 2.6 million tweets. So I think sharing features of data that you yourself create is one way. And another way is to use, any of the new, like just as, we have all these new problems, we have new fields studying them. So statistical disclosure techniques, there's, many fine R packages now that allow you to add some noise to data, all those we learned from Matt yesterday. These two can have some kind of potential for adversarial attacks. So I think it's a case-by-case thing. I mean, it's a thing where you really want to, again, go beyond the IRB limit. You want to consult colleagues. You want to take the user's perspective and share just enough data to allow people to reproduce your findings. And then, Matt and I, in both of our studies, have explored ways of creating kind of like restricted access to the data to allow kind of researchers to go through some kind of vetting process to better analyze the data. And there's other people who are looking into advances in cloud computing to handle that kind of sensitive data access. So for example, Amazon Web Services, which many of you may use to run your analyses, hosts a part of its servers called GovCloud, which is reportedly what the US government and the CIA uses for their kind of cloud computing. And you can kind of purchase space on those spaces, which could somehow with appropriate credentials, which are themselves, of course, easily violated, create some kind of safer space. But I think, the illusion of like perfect confidentiality and anonymity is, it's something where we continue to discover it should be our goal, but it's going to be really difficult to attain. Why don't we do just one more from the live stream, and then I think we better move on.
So, this participant asks, how do we de-identify the data to prevent sensitivity and privacy concerns if we want to match social media data with survey data?
Yeah, so I think the first thing is, the question is, how do we de-identify the data if our goal is to match or if part of our analysis is to match the survey data to the social media data. I think, there's ways of adding, of binning, for example, observations. So for example, you may be doing a study of, negative affect in discourse about eating disorders online, and that's a very sensitive data point that you could, for example, link young people to their online behavior. You certainly would want to think very carefully about somehow allowing people to identify those people. But if you had a very big bin, something like negative comment, these are things that I think can, with reasonable safeguards, and if you've, for example, pre-registered how you're going to define these using the principles of open science, for those of you who don't know them yet, then you can give us as a community some confidence that you're creating reliable measures. But at a certain point, I think erring on the safe side is really advisable. And it will be a situation-specific solution, and again, hold yourself to standards higher than IRB, consult your colleagues, and take the user's perspective. I think those are the best recommendations. Okay, I think we better move on. So now we're going to get into screen scraping, or as I like to call it, the word cloud of digital trace data. Word clouds being a nearly extinct form of data visualization that many of us remember fondly. Okay, why is screen scraping kind of going out of style? First, let's talk about what screen scraping is, and I'll talk about a lot of the challenges of screen scraping. But just big picture, if you are learning these techniques for the first time, and you are wondering how difficult it is to get up to speed in coding and extracting data from a website, screen scraping, though one of the more primitive approaches for collecting data, can also be one of the most frustrating and They're the enemy, they're stopping us from doing the cool research. Really, they're people over there who, want to understand what we're doing and want to help us do the research ethically, So having a very preliminary conversation about, here's what I'd like to do, here's how it would look like. I haven't yet written my proposal. Can you give me any feedback, or can we talk about possible issues? And you may become aware of, the need to specify how you're going to store the data that wasn't on your radar. So it might actually help you write your IRB application. But I think many people don't have that initial conversation because they think someone's going to say, don't do it. We're back on. All right, good. Do you know where we lost?
Yeah, do you want to rewind just a couple slides?
Yeah, started screen scraping again. Okay. Welcome back, the rest of the world. Sorry about that. We still working out AV kinks here. And I'm just not quite sure where I lost everybody, but we're going to start over again with the subject of screen scraping, which I mentioned is a somewhat primitive form of extracting digital trace data from websites. And for those of you who are new to the field and getting your feet wet, it is also a particularly it can be a particularly frustrating form of extracting digital trace data for reasons that I'll soon describe. So what is screen scraping? Screen scraping, for me, refers to downloading the contents of a website, extracting or parsing through the contents of that website for some piece of information, and storing it into a database, often in an iterative fashion. So you're kind of going through and picking up data points again and again and again. And the steps typically involve identifying some type of page that you can legally scrape, downloading some source code, meaning the actual guts or contents of the web page, and then parsing through that and populating a data frame. So the first question that you need to ask is screen scraping legal? And what you want to look for in most cases is the robots.txt policy at the bottom of a web page that specifies the conditions under which you are allowed to automatically visit the site and extract information from the site. Once upon a time, it was kind of the wild, wild west of computational social science. Very few sites had stringent policies on what you could and could not do, and many people collected vast databases, including of some of the larger tech companies like Facebook. What happened? Well, in some cases, those data were eventually published as part of really great studies that came out in really great journals. But the far more common story, from my perspective, was that these studies got shut down in one way or another. So when I was a postdoc in Michigan, 2 members of the computer science department received a cease and desist letter from Facebook after they had scraped some 100,000 profiles from the site, right? Why was there this crackdown? Well, there's a few reasons. Now it seems obvious in the post-Cambridge Analytica, post-emotional contagion study. We all understand now that these data are very sensitive, but it's easy to kind of have this kind of amnesia about what it was like back in the wild, wild west, when really it just seemed like, the more good content you could produce, the better. People hadn't yet, I think, realized the sensitivity of the data or the value of the data. And so many sites over time implemented increasingly stringent legal restrictions on scraping the site, which many people continued to ignore and continued to collect data. And that's a difficult decision that many people are forced to make. But as you consider making that, let me just give you another thought experiment, which is that you've spent 3 years carefully scraping data from a site that has a policy that explicitly prevents you from doing that, and it's the week before your dissertation defense and you get a cease and desist letter from that website, right? This is not a scenario any of us want to contemplate, right? Because it certainly could affect the publication process and so on. So we need to have better standards and better conversations, and I'm not a lawyer, you can't take legal advice from me, but I encourage you, just as I was encouraging someone here earlier, to reach out to your IRB officer early and often. Universities typically have an office of general counsel here in the States. I'm not sure what the international analogy would be, but these are people who are lawyers who work for a university who can help you read and understand these terms of service and can at least help you have some idea of the consequences of what you might be doing. So before you even think about screen scraping, consider whether it's legal. And what's important now is that it's not just the sensitive websites that have these restrictions. As technology for building websites scaled, the legal templates for specifying how people should use those websites also scaled, meaning that even websites that don't have particularly valuable or sensitive information may still have some type of restriction against collecting data. Okay, so screen scraping might be illegal. Screen scraping is also frustrating. One of the main reasons that it's frustrating is very often the site that you want to scrape is designed in a way to make it difficult to scrape the data. The data that you can clearly see in your browser is actually hidden somewhere deep in the guts of the website, in the source code, could be HTML, could be XML, and you have to learn how to find that part of a very long set of words and numbers that contains your data, and I'll show you an example in just a second. So if it's illegal, it's frustrating, and especially if your goal is to iteratively collect a lot of data across a lot of websites, you're not only going to deal with the idiosyncrasies of any single website as you go to scrape it, meaning how their web page is structured and where the information you want resides on that page, but then when you go to a wholly different organization's web page, they may have a totally different structure. You then need to write code that navigates that idiosyncratic structure too. And so say you wanted to scrape a lot of information from media or newspapers or some kind of online sources, you would be faced with potentially writing custom code to scrape, a large number of websites. And those websites may change over time, and that might break your code. And so there's a lot of frustration in screen scraping. And again, I'm teaching it today to give you a tool in your toolkit that I think you'll use one day, but you may be much better served by application programming interfaces, which we're going to talk about after the coffee break. So the first step in kind of any screen scraping endeavor is to simply read your web page into whatever software you're using. Today and tomorrow I'm going to be using R. I'm not an R evangelist. If you use Python, great. Whatever language, Julia, great. Whatever language you prefer is great. My advice is to learn one language well. And I think for most of our tasks in computational social science, either R or Python will serve you well. But the first step in any screen scraping is simply to read a web page into whatever software we're using. For screen scraping, I prefer the rvest library in R. So if you've gone through our pre-institute training, you've hopefully by now learned about installing an R package. This is the code that would do that for this particular package, which was written by the famous R developer Hadley Wickham. But it's actually a kind of a repurposed version of the Python library Beautiful Soup for those of you who are Python users. And after we install the package, we need to load the package using this library function in R. And we're going to begin by scraping a very simple web page from Wikipedia. So if you are following along with me today, the links to these slides are in our schedule and materials section of the main Princeton page. They may also be on the page of your specific site if you're at one of our partner locations. And what I'd love for you to do right now is pull up a simple web page from Wikipedia that we're going to scrape together. I'm not going to click on this link, but I would like you to do so if you're following along. There's one more word of advice. There's an argument for not following along. If you are a learn by doer type, I would absolutely encourage you to start coding or open up your own session of RStudio to follow along. If, on the other hand, this is your first time encountering this stuff and you're new to this stuff, remember that for each and every section of the materials, both today and tomorrow, there is an annotated code document linked on the schedule. And that summarizes most, if not all, of what I'm telling you here and describes what each line of code is doing. So if you want to try to kind of let the big picture sink in and deal with the details later, we've tried over many years, and many people have now contributed to that code to make it better. And again, if you are an expert and would like to suggest improvements to the code, this is one of the great features of this community, that we can make everything better. And if everybody makes our code better, then everybody can use that code. So please, to the experts, if you have recommendations, please submit pull requests by going to the Summer Institute's GitHub repo. And we have a folder marked 2019 and a folder marked materials. And there you will find all the native files. These are .rpres files, which is a format for creating presentations in R. And then there are R markdown files, which link the annotated code. Okay. So if you've now gotten to that web page, you're seeing something like this, the World Health Organization ranking of health systems in 2000. I've chosen a really arbitrary example, health and international health. And I've intentionally chosen what is a very simple web page. Wikipedia is a pretty miraculous, I think, example of an internet success story in many ways. And partly that's by being like lean and mean and having relatively simple and consistent code. So most Wikipedia pages we all recognize, right? There's a title, there's a subtitle, there's a kind of a table of contents. You know, we can kind of see the content we need pretty quickly in the page. And that could be advantageous if we wanted to, for example, scrape a large number of Wikipedia pages because they're going to have a pretty consistent structure. It turns out that Wikipedia has an application programming interface, which is the type of tool I'm telling you that I'm going to talk about in a few minutes, which is probably a superior alternative for extracting data from Wikipedia, depending on what you want to do. But for now, we're choosing a simple example with a consistent structure to do a relatively easy form of screen scraping. So this is what the page looks like to us. But what the page looks like to our browser is this. This is the source code of this page. So if you want to view this in your own browser, if you're in Chrome, by the way, I should have mentioned most of my examples are going to use Chrome. I'll try to, if you're using Firefox or Safari or other browsers, I'll try to give you instructions for those browsers as well. But if you are choosing between browsers right now, please go to Chrome. And if you go to Developer, the menu at the top of the page, and View Source, from one of the drop-down menus, you should be able to see the source code of any web page. And what you're seeing here is, this is HTML, and what you're seeing is somewhere in here is the content of the web page that we might want to scrape. In our example, we're going to try to get a table that describes health indicators for a lot of different countries, and we're just going to try to pull out that single table, the data that describe each country's rank in all these measures. But you'll see up at the top of the page here a bunch of like seemingly, kind of nonsense text. Some of this is doing things like defining the aesthetics of the web page. How big should the font be? How big what color should the font be? What font format should the page use? How should it be laid out? Meaning, where should different parts of the web page be rendered in a browser or perhaps on a mobile browser? And so there's a long set of instructions that your browser is using to figure out how to visualize the page to you. And the content we want is probably hidden somewhere deep in the guts of the HTML file. So what we're going to want to do is first read in all this data into R and then begin to parse it. And that means to use tools to try to figure out where the data that we want lives. So to download the actual HTML, the actual source code, we can use the read._html function from rvest. And that simply creates a new object that contains the source code. And in subsequent steps, we're going to try to parse through that source code to pull out the table of health indicators on that web page. And we're just here browsing to see what it looks like. And one of the first things we need to understand is that many web pages have a tree-like structure. Here we're looking at a common HTML structure, the head and the body. The head often reports the title and aesthetics, or sometimes known as CSS, as well as metadata about the page, maybe who wrote it, what organization created it, when, things like that. And usually when we're screen scraping, we want something that lives in the body of the page. That's kind of the content or guts of the page. And then within the body, there might be separate branches, paragraphs, headers, and so on and so forth, and subheaders and subparagraphs, and so on and so forth. And we need to figure out where the table that we want lives in this tree. And so you can imagine how painstaking it would be to scroll through that long mess and try to find that data, especially because a lot of these data have a nested structure, which makes it really difficult to, say, use Control F to try to find the piece of information you want on that page. Fortunately, there are tools that run natively within browsers like Chrome that allow you to identify snippets of character strings that allow you to parse the HTML more effectively. So earlier I mentioned the wrong drop-down menu. It's the View menu that gets you to the Developer menu. And from the Developer menu, if you choose View Source, then you should be able to see the source code that I was just talking about. The next step, though, is to come back to the regular page and to click here on Developer Tools. And this is a neat feature of Chrome that allows you to simultaneously browse the web page as you see it, and then browse the HTML. And essentially what we can do with this tool is click on different elements in the page as we see it, and illuminate the part of the source code or the part of the HTML where the data we want lives. So in our example, we're trying to scrape the data from this table here that has health indicators. And so if we come in here and kind of mouse over here and begin to click and interact with that part of the page, we notice that it begins to illuminate a part of the source code here. And this is that nested structure that I was talking about before. And we can see here that the data we want live within this branch of the HTML. And if we right-click with our mouse, we can then choose Inspect. And if we inspect, we then are allowed to use this copy menu to copy something called the XPath, which is a character string that helps us parse the HTML. It helps us figure out which part of the HTML data contains the data that we want. And so basically a lot of screen scraping, one of the reasons why it can be very frustrating, is kind of going back and forth, interacting with the page to try to generate this character string which helps us parse it. But as you might imagine, you might click on one part of the page that is actually something else. So you may have clicked on the flag for Estonia or something like that, and then that takes you to the link to the image file that is storing that flag. You'd have to click somewhere in the middle of the table, perhaps, to activate the exact XPath that you need. But once we have the XPath, and again, this could take some time, especially for a much more complex site than Wikipedia, we can then use the XPath to navigate the object that we created in the previous step called Wikipedia page. So that's when we read in the source code. And now we can simply add an argument to the function HTML node, which is a function that helps us parse the HTML, find the branch of the HTML where our data lives, and read in the XPath. This is what I copied from the web page when I made these slides. And then I can create another object, which is the branch of the HTML, or the node of the HTML, sometimes we use the terminology node, where the data we want lives. I've called it, very arbitrarily, section of Wikipedia. Lastly, once we're in the right branch, then we can use one of the functions within rvest. Rvest has an HTML table function, which allows us to pull out any tables in one node or branch of the HTML. And so I've used that here to create a new object called health rankings. And in this last line of code, I'm simply browsing the first two columns, which describe one of the health indicators and the country. And if we wanted text, we could use the HTML_text command. But typically, we want either text or a table or an image. And the rvest package should provide you with a guide to extract any of those kinds of elements. So the real trick here is figuring out the XPath in order to pass that to this function. Or if you're in Beautiful Soup in Python, you're going to be using a very similar type of workflow. Unfortunately, very often, despite a good faith effort, the XPath does not produce the type of data you were hoping to get from the web page. And luckily, there are multiple ways to skin the cat, as we say in the States. No offense to cat people. When the XPath fails, this is very often the case when we deal with a more complicated web page. So I know as well as anyone that the Duke page is very complicated and difficult to navigate. And so I can say, you know, if I wanted to get here, there's a part of the Duke page that's describing current events. And let's say I was, you know, interested in creating a scraper that daily went there and grabbed all the events. I don't really know what the social science purpose of this would be like, but let's just say I want to do some kind of iterative data collection from the Duke web page. Well, this type of web page, you can see it's a lot more sophisticated than the Wikipedia page. Why? Well, there's a lot of interactive features. There's some JavaScript here, which is determining like what happens when you mouse over something or interact with something. And maybe to produce the kind of data that I want, I might have to interact. That creates another layer of challenge when I'm trying to screen scrape. In this case, the data I want is hiding within a JavaScript or an element within the web page that will not be produced via the XPath. And here, a common alternative is to use something called the CSS selector, which is another type snippet of character string, which can be passed to the same type of functions we were using earlier in order to extract part of a web page. And the way that one can find the CSS selector is to use, one way to do it is to use this gadget or plugin for Chrome. And what this does is gives you a tool that allows you to, again, interact with the page by clicking on an area that you wish to scrape, then clicking on an area that you don't wish to scrape, then clicking on an area which you do wish to scrape, until only the area that you want to scrape is illuminated in green. This can be a very frustrating process and cumbersome process and deeply unscientific process, which is one of the reasons why I continue to say that screen scraping may frustrate you, especially as you enter into these more difficult pages. But after much laborious clicking, I discovered in this particular example that the CSS selector, which you can identify at the bottom of a page using the selector gadget here, it will appear here. You can also get the XPath through this tool if you prefer this tool to Chrome's tool. And then instead of passing the XPath here, I've passed the CSS selector, which is again this little piece of gibberish that tells me which part of the HTML contains this data from the Duke web page. I want to point out one more thing here, which is this is not quite the data we wanted. You'll notice we have these /n/t, etc. Why do we have that? These are known as HTML tags. These are instructions to the browser about how to, for example, indent some text or create a new line that we've accidentally kind of scraped. This type of HTML tag is kind of ubiquitous in a lot of digital trace data, sometimes even from APIs, depending on how the data is structured. And so we'll learn tomorrow about some simple tools to clean up these HTML tags. But if you're wondering what those are, that's what they are. And sometimes they can be easier or trickier to parse through. But it's yet another reason why you typically want to approach screen scraping. Again, if your goal is to scrape a lot of different kind of sites, now imagine how difficult it was to get data from one site that had a very consistent structure, and it was still difficult to get one that had a more complicated structure, but there are far more complicated sites than this that have legal restrictions that prevent you from collecting data from them, and that also change and have dynamic features that make it hard to scrape. And so you may find that, you know, in a lot of cases of screen scraping, you may be much better served by hiring, for example, Amazon Mechanical Turk workers to visit a list of web pages and extract some information that you want, rather than writing a custom scraper that might take you days or even weeks, depending on the complexity of the task to write. But it's good to have in your tool belt. And in addition to these two techniques that we've discussed so far using the XPath and the CSS selector, I'm going to go over one last tool for screen scraping. I'm going to suggest that you do not follow along with the code on these screens for a few reasons. The first is that this package that we're going to use, or this software that we're going to use, is called Selenium. It's a software that actually takes control of your computer in various ways, especially your browser. And so many people will be uncomfortable with that. It is recently approved by CRAN, the kind of central archive of the R community. but it has been taken off CRAN because of violations or kind of seeming vulnerabilities. So use it with caution. The other reason to proceed with caution is depending on your operating system, it can create real issues with your operating system that might require you to install an older version of Java, which is part of the guts of most operating systems. And if you do that, your Selenium code may work, but other things you do on your computer may break. So I'm going to advise not to follow along. There are some slightly nicer hacks that I've built into the code here, which will hopefully prevent you from running into some of these OS issues. For example, using Docker, which is a tool that allows you to use a virtual machine to do this, or a virtual instance of a machine to do this. But you're still going to find that this can be tricky to get up and running. But browser automation can be a useful tool if you need to collect information from a website that allows you to, but has some kind of interactive feature that you need to navigate in order to download the data. So for example, let's say you're going to a website and you needed to download CSV files repeatedly by clicking on a download data button, right? If the CSV was hosted as part of the URL, the thing we all put into our web browsers, we could simply scrape that, get all the CSV. That would be great. But very often on a lot of websites, you'll have to interact with the website in some way to produce the data that you want. And so what browser automation can do is say, for example, read in a list of different websites, maybe that have different URLs at the end. If you're looking at, say, different countries and each country has a CSV and you want to download each one, you can then send instructions to Selenium about which URL to put into your browser, and then tell Selenium which part of the web page to click in order to download the data that you might want. And so to do that, I recommend this software Selenium. The R version is called R Selenium. There's also a Python package. You may need to consult this tutorial to get up and running, and you will also need to install Docker, which helps you create the virtual instances you'll need to run Selenium using my code. You'll also need to run the system command from your R code editor or from your terminal if you're familiar with Bash in order to install R Selenium within Docker, which is the virtual machine tool that we're using. And then in our Selenium, we need to essentially create a new object. Here we've called it RD for remote drive, and a new client, which is Selenium speak for kind of like a new browser instance. And then once we've done that, there are a suite of commands that we can index using this operator to different places. So if I wanted to visit the duke.edu webpage, once I've loaded up my browser, if you were running this code, you would see much like a player piano, you know, like pianos that play themselves. You've all seen these. It's kind of like that. A browser opens, and then all of a sudden you see typing coming in up into the URL, and the browser begins to navigate to the page. And then if you use tools like this, we can use the CSS selector to navigate to the part of the page that we want to press or enter text into. And so we'd have to use one of the aforementioned techniques to find that part of the page that we want to interact with. And then we can pass arguments into this find element function, which helps us find the part of the web page that we might not want to navigate, and put in some type of code. So here it might be hit enter or click the mouse or something like that. And here we are, we're searching the Duke web page for mentions of data science, and this here refers to the keystroke for hitting enter. So literally, we're opening a browser, we're sending it to duke.edu, we're telling it to put the cursor on the search bar, we're telling it to put in write in data science, and then we're telling it to hit enter, and then we get some type of data. Now, quite obviously, if you're using screen scraping, you're doing it because you want to somehow iterate this process, do it again and again and again. And so you likely want to create some type of loop if you're doing this. Here's an example of a kind of template example of what some screen scraping might look like. If you are new to R, if you are new to open source programming, this may be a little intimidating. Essentially, what we are doing is giving our R console here a list of websites. Then we're creating a place to store the data that we're scraping out of those websites. We need to do that in our loops. And then we need to write some code that tells, that provides a set of instructions to be repeated within a for loop here. And we're telling R to do this for a number of times that mirrors the length of the number of things we want to scrape. And then we simply pass all the types of code that we used in earlier steps to extract the data that we want. And then we bind that data together using, in this case, the rbind function. And then we do that again and again. And that's the basics of a simple, though I think non-functional code. Why is it non-functional? Because the Duke edu page and the append.edu page have a different structure. So this is an example of how we'd have to have some kind of exception or if loop that told our code what to do if it encountered a Duke page versus a Penn page, and then we'd have to kind of change things up. But that's the long and the short of it. When should you use screen scraping? I think this is the question to ask because, again, we're about to learn about what I think is a superior alternative. You should use screen scraping when you're encountering an older site. So many government sites still have an old structure that allows you to scrape them. Many universities have older websites that allow you to scrape them. And sometimes you will only want to navigate one page to figure out some feature of the page that then you're going to use to interact with in some other way for some other type of experiment or project. And learning how to navigate HTML is a kind of fundamental tool that you will likely run into sometime if you have not already. So although the uses of approved and legal uses of screen scraping are diminishing, there are still cases where it's good to know. And if you do use it to extract large amounts of information, be prepared again to do a lot of jujitsu with the web pages and custom kind of tweaking for the idiosyncrasies of each page. And you may also run into something known as rate limiting, which we'll talk about in a little bit, which means when you make too many repeated requests to a web page, you can get shut down by the server that hosts the web page or the web page itself. Okay, questions? We're behind schedule because of the AV mishaps, but are there questions here or on the live stream? If not, I think we should go ahead and take our break just so we don't get too far behind for the rest of the day. Tom, are there aren't any questions?
Nothing.
Okay, good. So we'll be back, let's say 10 minutes. We had originally scheduled 15 minutes, but we lost about 10 minutes in our Check one, check two. Check one, check two. You guys hear me? All right, on behalf of the Sloan Foundation, the Russell Sage Foundation, and Princeton University, it's my pleasure to welcome you back to SICSS. In this next section of the content, if people in the room could please, the rabble-rousers could please calm down here. We're going to move on to the next in our series of topics on digital trace data. We're going to spend the next half hour to 45 minutes talking about application programming interfaces. So what is an application programming interface or an API? An API is kind of a tricky concept to wrap your head around, but we all use them kind of every day. You can think of an API as kind of a pipeline that allows us to make custom requests for different types of data that we might use to, say, integrate multiple databases on the internet to build apps or to make websites run, or increasingly to do things like analyze our data, as we'll talk about at the very end of this section. But you know, if you think of a large website, the chances that website has an API are very high. Why are they high? Well, somewhere around, I don't know, 6 or 7 years ago, we entered, you know, what many people call like the Web 2.0 environment. So as I mentioned earlier in the first stage, it was kind of the wild, wild west. Everybody was grabbing data everywhere. Then, pretty abruptly, everybody started guarding their data. And that was because of some, you know, very unfortunate initial disclosures in the data. So for example, America Online, which used to be one of the premier providers of internet service, released for research purposes a list of web searches by a large group of individuals. So as you can imagine, this is potentially very sensitive data, and it wouldn't have been a problem were it not the case that many people Google themselves. So as soon as someone Googles themselves, especially repeatedly, you can then infer what they were searching, right? Which is a huge violation of privacy, in my opinion and in many people's opinions, and led many other Silicon Valleys to kind of stop sharing data with researchers, but also more broadly was kind of a harbinger of things to come, which is to say a kind of a massive shutdown on sharing on the internet. Then when Web 2.0 came around, you know, social sharing became such a linchpin of the internet. If your website couldn't be integrated with other websites and share data readily, then you were going to also face kind of dire consequences, right? So if you're Facebook and if you can't give people a tool to share New York Times articles or Spotify songs or whatever, you're also going to lose competition. You're going to lose your competition, right, to another social media platform or something like that. And so APIs, though not particularly new, are a technology that allow data to be transferred across sites. The tricky thing is, and the reason we need a new technology is not everybody should have access to all the data on all the sites. And so essentially what APIs do is regulate who gets access to what kind of information, how often they can access it, and in many cases kind of sets rules for what they, or tries to set rules for what they can do with it. So this, you know, super awesome infographic here gives some examples of what, you know, an API might do. It's this kind of yellow band that connects all of these different structures on the internet and allows information to flow between them. Although, as I'll say at the end, that what APIs can do now is actually going beyond just sending and transferring information. So APIs have kind of pretty spectacularly grown since around 2006. By January 2018, we were up close to 20,000, and I think now we've easily surpassed that measure. If you're curious, you can visit Programmable Web, which is a website that tries to track all the APIs in existence, or at least the public ones. Many APIs operate only within a company and are not public-facing APIs. And so there's this real explosion of this technology, and many of the most popular websites have an API. So if you go to this link here, and again, the slides are linked in the schedule on the Princeton web page for today, you can visit a directory of all of these APIs, some 20,000 and counting, and they're easily indexed by different types of fields. So if you're interested in health, there are health APIs. If you're interested in GPS data, there are GPS APIs. If you're interested in media data, there are, the New York Times, the Washington Post, most large media organizations will now have an API. They will vary quite a bit in what type of information they share it with you and how they share it with you and how much they'll share it with you. But it's a great way for the kind of pioneering young computational social scientists to try to get a sense of what data is out there. Because very often when students set out in social science, they look at the very well-formed data sets, the General Social Survey, the American National Election Study, the census, something like that, and try to find their research question. And what both Matt and I have been adamant about now for many years is like, why not build your own data? Like, why not create your own data set? It's easier than ever, and there's just this wealth of unfarmed data. Now, a lot of this data is not usable for social science purposes. Returning to our earlier discussion of ready-made versus custom-made data sets, these are all ready-made data sets, meaning they were created for a different purpose than social science research. I guess there are a few exceptions like bibliometric APIs, which are primarily designed to enable scientific research of science. But generally speaking, Facebook's API was not designed primarily with social scientists in mind. So maybe after this lecture, or maybe you've had a chance to check it out by now, go to this link and take a look at the really stunning number of APIs that are out there. So we're going to do an extended example with Twitter towards the middle and end of this lecture. And the reason for that is that Twitter is one of the most open sites on the internet. It is by definition primarily public, unless you have a private account. And it allows you to collect quite a bit of data about a range of different issues. But before we get into working with a relatively complex API like Twitter, we're going to try to take a baby step first, which is to use a Google API to geocode a term. So what we're going to do is take a chunk of text and try to return the latitude and longitude associated with that text. We're going to look at like the name of a city. And the way that we do that fundamentally when we're using APIs is to make an API call. And so here's kind of the anatomy of an API call. First, we have what's often referred to as the base URL or the base API URL. This one we're using today is called maps.googleapis.com. And this is one of over 100 APIs that Google maintains. So Google has various search APIs, various map APIs, various advertising APIs, a lot of APIs that do things that social scientists might not be interested in, but it also has a translate API. It also has a variety of tools that will be of interest to social scientists, and certainly the Maps API can be useful, particularly if you're interested in geography or GPS, or even producing lists of named entities for your research, such as businesses or other organizations. So every API call begins with some type of base URL, and then we request some particular field or data from that API. So here we're looking within the maps field and the API field and the geocode field. Why are they called maps and API? Well, that was just some software engineer's convention for naming at Google, so don't make too much about what that exactly means. Indeed, one of the main challenges in working with APIs is learning how to decipher the API documentation, which is typically a large website that describes what types of names are given to what types of data and how you're supposed to construct your calls to get that data. But in the case of Google, that's what this looks like here. The data we want, which is we want to encode the latitude and longitude of Duke University, and we're using that with these fields, geocode, API, and maps, or these folders. And next, we're making a request for JSON data. That's the type of data that is very often returned by APIs. Sometimes we might get XML data as well, but JSON is very common. And finally, we have our query, the thing that we want to subset from the very large database of known latitude and longitude in the entire world, which is the term Duke. We would get a different result searching for Duke in, say, the United Kingdom than we might in North Carolina, where Duke University is in the US, because Google will probably use a bounding box for searches around our kind of local geographic area from where we make the API call, but let's forget about that for a moment. Basically, what we're doing when we're constructing API calls is looking for generic structures of a URL and then switching out one term. So suppose we wanted to encode a list of dozens of known universities. And we had a long list in some kind of data table or some type of data frame. And we wanted to just simply switch out Duke and then Princeton and then University of Illinois and then University of California and so on and so forth and get the latitude and longitude of each one. Well, what we'd do is we'd write some code, and each time through the code, we would switch out the name that gets entered. And then essentially what we're doing is scraping the JSON data from the browser. I mean, that's a little bit of a conceptual leap, but basically what we're doing is grabbing the data that results from the URL call in our browser. So if we put this string into our browser, we get something that looks like this. It may have changed recently as Google has been shifting its criterion for the amount of data that can be accessed and whether one needs specific credentials or codes to access the data. But it should look something like this if we've constructed our API call properly. And here what we're seeing is all the data that Google knows, or the Google Maps API knows about the term Duke. And somewhere hidden deep within here, which you can't really see, is the latitude and longitude of Duke University. We're also getting some data on the state that it's in, the county that it's in, the country that it's in, and so on and so forth. I think the census tract that it's in. And so then the next step is to parse through this, just like we parsed through the HTML. But the nice thing about parsing JSON is that it has a reliable and consistent structure. So it's typically a list, so there might be character vectors or numeric vectors or even data frames contained within the JSON. But we can use the atomic operator, the $ in R, to index the JSON object that we create to extract those fields. I'm not going to say much more about how to do that because I want you to get the intuition about how an API works from this part of the lecture, but I don't want you to yet write your own custom API calls like I've done here. Why? The answer is because there are many fine packages in R or modules in Python that will do this for you. So they construct all the complicated syntax, they sift through the massive and Byzantine API documentation that you need to learn how to use in order to construct API calls, and let you quickly and efficiently do the things you need to do to get the data from the web page. But I want you to know how, like the fundamentals of how an API works in case you, say, want to use an API that doesn't yet have an R package or a Python module that allows you to neatly construct the calls, or if you wind up building an API yourself or many other features, it's kind of just good to know what's actually going on underneath the hood. But for now, we're not going to spend time parsing the JSON because we're going to use other tools to do that. So if we wanted to design our own API calls, right, we just have to switch out the field, the query. Maybe we want different types of data for different types of queries, and we would fold all that into some type of loop and repeatedly request data in an iterative fashion. Okay. So the first thing you need to know about working with most APIs is that most of them require some type of credential. This is some type of character string that announces you, the developer. You need to think of yourself as a developer if you're going to think about using APIs, because that's most of the people using APIs are software developers. You have an identity. Your identity and your credentials, this long string of text and sometimes numbers, allows you access to certain types of data on the platform. It prevents you, at the same time, from accessing other people's data that you're not supposed to have. And it also determines and tracks how much data you request and in what timeframes. And these are all really important things for the owner of the API, right? If I really want to know what's going on Matt's Facebook page, but he hasn't responded to my friend request yet, jerk, then I need to, I can't just go in and put, his name into Facebook and scrape his data, right? Until he finally accepts my friend request, I can't see his data. And that's a good thing, right? There's a purpose for that. Likewise, if I sent a request for all the data from, Elizabeth Warren's Facebook page every single second of every single day, eventually it would overload or overburden Facebook servers, and they'd have to deal with my requests instead of dealing with the request to load that page from any number of people who also want to see it. So the owner of a web page, of an API also needs to limit or rate limit the amount and number of requests and the frequency within which they can occur. So the first thing we're going to grapple with is credentials. That's the codes we need to define ourselves as one who has the right to use an API. And then rate limiting, which is the process of knowing how many calls we can make within a predefined period. So the process of credentialing, or getting these codes that allow you to access the API, varies quite a lot across sites. We're going to look at a quick example here with Facebook. So if you navigate to this link here, this is something called the Graph API Explorer. So Facebook's API is called the Graph API. And basically what this is a sandbox, meaning a web-based environment that allows you to play with the API, try out some API calls without really, in a very small scale and without really messing anything up too bad. So basically what you'll see if you go here, sorry, I don't have it open, but basically you'll see here is something very similar to the Google page that we saw earlier. You'll see some search bars that allow you to put in fields like a user's name or a user's birthday or an organization. And if you experiment with that, you'll pretty quickly see that you are not allowed to get access to most of the data on Facebook. You can, with this Graph API Explorer, explore your data. You could pull, your birthday from that data if you've shared that with Facebook. But you, again, couldn't get anybody else's data. Why not? Because the temporary credential, which you've been given to use this page, is generated by this tool, and it only allows you to see the data of you, the logged in user, or any content on Facebook, which is by default public, and at that, only a small amount of that data. So really, this is not very useful for social science right now. Again, generally speaking, Facebook's API has become increasingly restrictive to the point where, unless you get credentials to access someone's data, you're not going to generate a lot of Facebook data unless you're collaborating with Facebook. We'll talk a little bit later about how you could build an app that could allow you to get credentials that allow you and request a user's permission to access their data, which then can allow you to make a request, a legitimate request. But that in so doing, as you're requesting that authorization, you are actually changing your credentials as the owner of an app to access that data. So basically, credentials, broadly speaking, refer to your identity before the API that is defined by your level of access to the data. You, in the case of Facebook, should only be able to see your stuff, your friend's stuff maybe, but nobody else's, right? Other APIs will be very different. Some APIs are fully public. So you can, for example, go and get data, whatever kind of data you want from them, and you don't need any credentials. Some are public, but still require credentials to make sure you don't make too many requests within a short amount of time. Other APIs require you to pay. So there may be like a privileged level of access to get better data or more data fields, and you might have to pay a monthly subscription, which is then actually changing the meaning of your credentials before the API and allowing you to get more data. So the key concept here, though, is that these credentials are something that's very important in the process of making API calls. Typically, the first API call you have to make somehow authenticates yourself before the API and announces who you are and allows the API to determine what type of data you're supposed to get access to. So that's credentials. The second kind of thorny challenge with working with APIs is what I mentioned earlier, rate limiting. So this is the threshold at which the API you are trying to extract data from will stop you from getting data within a certain time frame. So this is the case where if you make millions of requests for information from a single page in a short period of time, instead of getting the information maybe after your 100th request, you might get an error message that says something about an SSL error or an OAuth error. This is the API telling you that you no longer have approval to get that data. Typically, the process works in as follows. So you make too many calls, you get rate limited. That generates, hopefully, some type of error message, though not always, that you might see in your browser if you were putting URLs in the browser, or that you might see in your R console if you're repeatedly making API calls, or in your Jupyter Notebook, or whatever you're using. And so once you see that, you can pretty reasonably conclude you've been rate limiting. The next thing you will surely want to know is how much data can I get within what type of time frame. We would all love every API to list that on their webpage, on the API documentation, right? Some do, as we'll see. Twitter allows one to make a call that asks how many calls I can make within a certain type of period for certain types of data, but many APIs do not. Why don't they? Well, if you do the thought experiment, if I was some kind of nefarious actor and wanted to, say, disrupt Facebook, if I knew exactly when they were going to rate limit me, I could launch many virtual machines and push them all to the very limit of rate limiting and do a kind of simultaneous swarm attack and thereby create a lot of problems, right? So if they're announced publicly, it's a double-edged sword. On the one hand, as researchers, we like that because we know what the rules are and we can stay within them. On the other hand, as a company, that creates potentially a vulnerability. And so very often what we see is a kind of cat and mouse game with rate limiting. So you make some calls, you try to guess what the rate limits are, but the rate limits can be defined by features that you're not seeing. So you may have a certain amount of requests you're allowed to make every 15 minutes. You may have a certain amount of requests you're allowed to make in your lifetime. And when you get rate limited, you might not know which of these rate limits you violated. So that's a bit frustrating. We'll see with Twitter, there's some good tools to use to help you figure that out. But if you're, for example, working with a high volume of Facebook data, you might run into this issue, and it can be difficult to figure out exactly why you're being rate limited. Okay, so everybody have the big picture of credentialing and rate limiting. Are there any questions, either in the room or on the live stream, about what an API is, what credentials are, what rate limiting is, or what these URLs are that we're constructing to produce data? Yeah, Victoria.
Just if we were following along with the maps, the Google Maps
Yeah.
API that you gave us, what would we have to put that into? The read HTML?
Oh, no, you could just literally put that in your browser. Like, just go to Chrome and put it. You could put it into read HTML if you're using RVS, which we used in the previous step. But I usually, for illustrative purposes, would just put it into Chrome. And as I recall, I think sometimes people, I think Google, as I mentioned earlier, may have just changed its API so that you may need to have credentials. Is everybody getting an error message? Teachable moment. Okay, so this is like, APIs are dynamic things, right? Every year of the Summer Institutes, I've had to rebuild all of these slides, much to my chagrin, because each company is changing what they do. So it used to be that Google would allow you to make a request for information without credentials. What I think we're seeing now, given that you guys are getting an error message, is that Google is now requiring credentials for any API request, even a single API request. But we can certainly look into that. Maybe someone in the Slack would be so kind to look into that and get to the bottom of it. I seem to remember that in the back of my mind somewhere, reading about that. But we need to do a little more detective work to figure out exactly why it didn't work. But thank you for bringing that up. Okay, other questions? Anything from the live stream?
There's a question that I think is better for the lecture.
Okay, all right. Okay, so now we get into some more fun stuff. We're going to obtain credentials to access Twitter's API and make a number of calls to collect data, network data, text-based data, which we might analyze tomorrow, and various other kinds of data from Twitter's API. We're also going to use the API to run bots that we'll talk about in the next section. But before we begin the process of developing credentials, let me just say a few words. First of all, we are, in the eyes of Twitter, announcing ourselves as people who want to use the API. So we're about to go through the application process to register as a developer. Maybe some of you are already registered as Twitter developers, but if you're not, if you go to apps.twitter.com, you'll have to have a Twitter account, and you'll have to have a Twitter account that has two-factor authentication that actually has been verified with a mobile phone. Why do you need to use the mobile phone? It is because this discourages the use of fake developer accounts in the eyes of Twitter. It didn't used to be that way, it is that way now. And so you can go to this website, begin the process of registering as a developer, and then we're going to begin the process of creating our first app. We need to create an app in order to get the credentials to make our API calls. The somewhat tricky thing is that we're actually not really going to build an app right now. We're simply trying to get credentials to get our feet wet with getting data. But conceptually, and again, remember, most of the people using APIs are actual software developers who are building apps. You're going to need to give your app some type of name. I recommend this process can take anywhere from 10 to 15 minutes for Twitter to review to, I've seen, as long as 2 weeks. So you may not get your credentials today. I can tell you that I would recommend specifying what you want to do with your credentials. You might, if this is the first time using the Twitter API, you might say taking a class on APIs and text analysis as part of the Summer Institutes in Computational Social Science. If we all use some kind of consistent language, it might not flag things on Twitter's end. But invariably, at least one student every year has a lot of trouble. And I can't tell you exactly why that might be. It might be that Twitter has some kind of flag for, some type of user behavior or something that I can't say because Twitter hasn't made that public to my knowledge. So if you go to apps.twitter.com, and if you need to create a Twitter account, you can. If you don't want to follow along, you're under absolutely no obligation to create a Twitter account or follow along. But if you do want to get the data and follow along, you will have to go through these steps. You'll have to apply for a developer account. You'll have to add account details. You'll see there's two types of accounts you can apply for. One is for personal use, and one is for organization use. Our lab, the Polarization Lab, has an organization account. That allows you to allow multiple users to use one set of credentials. But for your purposes, you're going to want to choose the personal account. The organizational account has an additional layer of scrutiny that will delay getting credentials. Then you'll have to answer some questions about your use case. You'll have to accept Twitter's terms of service. Each and every one of you will read every word of it and carefully digest its meaning, and then press accept. And then you'll get a response by email that announces Twitter's decision. And again, probably one or more of you will get denied. And this process I've been trying to figure out from both inside and outside Twitter, and I don't have a good set of answers to you for exactly how this process works on the other end. I can say, though, if you do get denied, usually there's like an appeal process, which they simply want more information about why you're requesting permission. I'm a little bit nervous that we're simultaneously making 300 accounts requests simultaneously from 11 different parts of the world. And so if those of you in other sites experience challenges, apologies for that. I don't know of a better way of solving this problem. Hopefully, at least one or more of you can get access, and then you can follow along with your neighbor, or if your site organizer has credentials, which many or probably all of them do, they might be able to showcase the techniques. And I'm going to be showing you what it would look like if your credentials were working. I'm going to give everybody a little bit more time to get through these screens. And I'm going to begin going through the process while we are doing the hardest part, which is while your application is under review. So if you've successfully completed the user registration account, you will have gotten here. You may get asked for your website. You can put in your personal website if you have one. In my experience, you can put in many different types of websites, like your university's website, and I think the main reason you get asked for this is because, again, most people using APIs are developing an app which actually has a location on the internet, which then specifies the terms of service of the app, the privacy policy of the app, and in many cases, the Twitter review team is probably visiting this website to ensure that your app is safe and has appropriate safeguards for user privacy and things like that. But in your case, if you're clear in your use case request that you are simply requesting access to begin learning how to use the Twitter API, I hope you will get approved. So, with apologies to everyone who's still waiting, and again, I assume most people are still waiting, you will eventually reach a screen that looks something like this. This is an app I built for my undergraduates to help them make API calls to study celebrities on Twitter, everybody's favorite topic. And basically, what you'll see once you've got an app that's approved is the name of the app up here. And then you'll see a variety of properties of your app. This one is not through the Polarization Lab. This is a personal account. And then you'll see here I've blocked out this field here, which is called the consumer key. Twitter, for reasons I don't fully understand, gives you 4 different types of credentials, whereas many APIs just give you 1 credential. And basically, you access those by going to this Keys and Access Tokens tab. And there you'll see these 4 different types of credentials. And you need to cut and paste those credentials into your R console or your Jupyter Notebook or whatever you're using in order to make your first API call to authenticate yourself as someone who wants to use Twitter's API. One other thing you'll need to do, you'll see here there's a field called callback URL, and this URL here is the IP address of your computer or your browser. And what that allows you to do is authenticate via your web browser as someone who is using the app. So you've built this app, then you as the logged in Twitter user then have to click accept, I agree to share my information with the name of my app. Kind of silly, right? But we're going to write some R code that will then open your browser and produce a authentication dialog where you have to accept that the app is trying to use your data. And then once you do that, then you'll get a kind of a success message in your browser in like small Courier New font. And then you will be allowed to begin making requests for data. So we'll walk through those steps, but I just wanted to give you a sense of where we're going. So you will need to, in your app, change the callback URL to this URL. And the reason you need to specify this one again is so that your app will open in your browser. You can imagine if you had built some kind of sophisticated app for the New York Times or something like that, it would have its own IP address somewhere else, and that's essentially the address where you're telling Twitter, this is where I want you to talk to me at. And so for the browser-based authentication that we're going to do, we're going to want to use our browser. This is how we get there. OK, so here's the page that I mentioned that contains all of your credentials, your consumer key or API key, your consumer secret, and your API secret. And your codes will appear here. They will be long strings. Here's your access token and your access token secret. And these are the 4 codes which together allow you to authenticate with Twitter. Over the years, Twitter has changed as to which combinations of credentials it requires to allow you to authenticate. The safest way is to put all 4 of them into your code, I found, though sometimes you can get away with just putting 2 in. As you cut and paste these, you have to be very careful not to either cut off the very end of the string, which is a very long string of letters or numbers, or accidentally add spaces to your strings. One of the main challenges people have in authenticating with Twitter is often simply that they are unable to, they inaccurately define the string that we're going to use, the string object or character object in R that we're going to use to pass to an R package we're about to use to authenticate with Twitter. So just take great care as you're cutting and pasting. For now, if you've got access, you can cut and paste them into your RStudio console, or you can come back to this page. And again, I assume many of you are still waiting for your developer account to go through. And if this is the case, you can simply follow along and maybe start up your calls in, say, 5 or 10 minutes, hopefully, or hopefully within the next few hours. There are a lot of different packages for using APIs, as I mentioned. There's a really nice one for Twitter called rtweet. There was an earlier variant called twitr, written by some of Kevin's colleagues at NYU. This one is written by Michael Kearney. There's a pretty good community of people who provide support for it, meaning when something breaks, people come together and fix it. And so, you know, as is true with any open source software, you know, it's buyer beware, right? There's no consumer advocacy or, you know, really sophisticated user support. If you have issues, the best resources are probably the GitHub repository for that package, where you could track issues. So a good old-fashioned Google search for the error message you might get in your R console could direct you to a GitHub issues page where people are discussing how to solve a problem or what needs to be fixed in the package, or provide a temporary fix for you, hopefully. Or sometimes Stack Overflow, the site which many of us use to discuss solutions to coding challenges in many different languages, but including R and certainly Python. And there, if you've never used Stack Overflow before, the convention is to ask a question with some sample data or use case. And the reason that you are asking a question with something that another person can reproduce on their computer is to make sure that you are not having some fundamental reading in data error or some kind of unique property of your data that is producing an error message that other people can't help you fix because they can't see the error message on their machine. So the convention, when you ask a question on Stack Overflow, lest you inspire the ire of many anonymous software developers, is to share some type of snippet of your data or some sample data and then reproduce the issue that you want. Say you want to restructure data in one way, you might say, my data looks like this and I want it to look like this. Then users will provide solutions to your problems, and those solutions will get upvoted or downvoted, and the best quote-unquote answers will rise to the top. The ones that get upvoted the most will appear immediately beneath the Stack Overflow question, and those often, but not always, provide some of the best solutions to your problem. So if you're new to Stack Overflow, maybe read it a while before you start asking questions, but once you're on there and learn how to navigate it, between GitHub and Stack Overflow, you'll find many of the best answers to any and all coding questions. So fortunately, as I mentioned, rtweet is a package that is relatively stable, meaning like it doesn't break too often, and it is pretty broadly used, meaning there's a lot of people who care about keeping it working, myself included. And so we can install our rtweet package like this, install.packages. We need to load the library. I'm missing that library function. We need to write library rtweet before we can begin using the package after we install it. But the first thing we can do is we can take the codes that we got from that developer page where we created our app. So we have the app name, the consumer key, the consumer secret, the access token, and the access token secret. Why is it called an access token secret? Why is it called a consumer key? On Facebook, it's called an authentication token. Again, these are the somewhat arbitrary decisions of some software developer somewhere deep inside a company. So don't worry too much about what these words actually mean. They're simply codes that you are using to establish your identity vis-a-vis the API. So you would be cutting and pasting your credentials, these codes that, again, you get from the other page, in between double quotes. That's a string or character object, which we define using these different objects here. We define as these objects here. And now we're going to begin using functions within rtweet that are going to stitch together very long API calls, very long URLs that include the names of the fields that we want. Say we might want, to see Matt's Twitter timeline or something like that. But also our credentials. And the order in which credentials appear and the characters that appear before and after our credentials define whether or not you can authenticate. And this is the painstaking work of navigating the API documentation, which can often involve looking at sample calls. But it can be very frustrating if you, for example, leave out one and sign or one plus sign or one underscore. Your API call might not work. And so we love packages that do all this work for us because we don't have to suffer through all the API documentation in order to figure out exactly what's working. Just as earlier I was saying, if you find screen scraping frustrating, it's screen scraping, not you. Very often, it's the API, not you, that's causing an issue. And it's about endurance as a coder. It's about, so looking at your resources, communities like this, our Slack channel. Has anyone ever had this error message with, our tweet package? That's a great, phenomenal resource. And remember that after the Summer Institute, we continue to maintain a Facebook page, we continue to connect on Twitter, and we're hoping this year to keep the Slack going, though last year we exhausted the messages after the first week. So we'll see, we'll look into doing that. But bottom line is there's a community around you, remember that, and in the absence of a direct contact who might know, like someone at this institute, you've got Stack Overflow, you've got GitHub. Okay, so this is what it looks like when we make our first API call, which is announcing our identity to Twitter, that is allowing us to make subsequent calls for all types of information we might want. First, we're going to load the rtweet package, like I mentioned earlier, with our library function. Then one of the workhorse functions within the rtweet package is this create_token function. There, we're passing all of the objects we created in this previous step, the app name, consumer key, and so on, which we've now defined as these R objects, in this function here. So what this is doing is taking all our unique codes and stitching them together into a really long URL, then ingesting the JSON, parsing the JSON, and returning, or actually in this case, it's making a call to load our web browser via that callback URL that I was talking about earlier, and then you'd see that authentication dialog in your browser that asks you to authorize your app to collect data. If we don't take this crucial step of authenticating, we won't be able to do anything else. Every API call we make will result in some kind of authentication error. You might see the term OAuth or SSL. That's indicating you have not yet successfully authenticated. Okay, but if you have, and now that you've gone through the process of credentialing and you've built your app, you've got your developer account, and again, all APIs will vary in how this credentialing process works and how authentication works. But in Twitter, we're now in, and we can now begin to make calls for data. So on the day that I made these slides, North Korea was in the news, and Korea, and so I decided to make a few examples around Korea. We're going to use the search_tweets function to search for mentions of the hashtag Korea, and we are searching for 3,000 tweets. And we've decided not to include retweets in this call. So when we make this call, by default, we would get people who are repeating that. And this simply shuts that off so that we get unique tweets about the Korea hashtag on the day in which I made these slides. And from that, we're creating a new object called Korea tweets. Our tweet is not only handling all our authentication for us, it's creating the long URL, it's ingesting the JSON, and then it's parsing the JSON into a beautiful square or rectangular data frame that we can then do whatever we want with. And that's really handy. So if we look at the tweets, we have a data frame now. We're browsing the column names using the names function of all of the different fields that we get from the Twitter API for this type of call. We get the ID of the message, the user's ID, the text of the message, a bunch of fields that help us determine whether someone's replying to someone, retweeting someone, and so on and so forth. Yeah, we've got a question.
I just want to know if anybody else is getting this error in create token. No?
It's a very common error message. I suspect it has something to do with your credentials or the way they were entered. If one of the TAs could check out Victoria's, do you guys mind?
There's a comment in the Slack.
Yeah.
Oh, you got it. Okay. And is that shared in the main Institute channel or in the Princeton channel? I just want to make sure. General. Great. Okay. Great. So great. Okay. So that's anybody else having issues so far? Okay. Usually we get issues because, again, APIs are living creatures that are changing and constantly frustrating us. You'll notice a lot of different fields here. We've got a language field. We've got a coordinates field. That's going to give us the latitude and longitude of the user who produced that tweet, provided that, and this is important, that user has agreed to share their location with Twitter. By my last analysis, about 1 in 100 Twitter users does that. And so that's a very relatively small population of people. However, many people are excited about using a variety of NLP tools in order to increase the rate with which we can geocode tweets. How reliable those are is a matter of some debate, but we can talk a little bit about that in a minute. And here you're seeing a lot of different other fields. The screen name, that's the Twitter handle. Once again, we have to live with the somewhat ad hoc or idiosyncratic decisions of the developer in naming all these fields. So why they used screen name and not handle, I don't know. In Twitter speak, if we're talking about someone's followers, we say followers, but if we're talking about the people that user follows, we talk about friends. These are just conventions that were made inside Twitter some time ago that we now just have to accept as the way that data is structured. But again, different APIs will have different names for different types of data. So if you've got in now, maybe you've got this data frame open, you're able to browse around a little bit, see what Twitter data looks like. Here's what the text of the first 5 or 6 tweets look like from the data on the day I collected it, which I think was last year. And we could browse through a lot of this text in many different ways, and tomorrow we'll be analyzing this using automated text analysis. Our tweet package has a number of built-in functions that do some handy things, like this function, tsplot, stands for time series plot. That is going to allow us to use ggplot, the popular visualization software in R, to produce this type of graph, which shows the frequency of tweets about the Korea hashtag for the past day. You'll note that we are getting, we're only getting the last day of tweets. One thing that's very important for you to know about Twitter data is that if you want to get retrospective data going back a long period, you're typically limited to the last 24, 48, 72 hours, depending on your process. Oh boy. Of course. Sorry, for everybody on the live stream, we've got a fire drill, I think. So this is very unfortunate. As soon as we can. let's get started. We're now very behind, and we have a lot more content to cover. Welcome back to those of you who are interrupted by the fire alarm here at Princeton. They're very precautious, these Princetonians, and we are back online. We were talking about making our first calls to the rtweet package in order to plot the frequency of tweets about the hashtag Korea over a 48-hour period. And I was just making an important point, which is that if you wish to get retrospective data from Twitter going back more than a day or a few days, you have somewhat imperfect options. One option is to buy the data from Twitter itself, from a company that it bought, which is called GNIP. That can be extremely expensive. When last I checked, I haven't looked in a while. Or you can identify a different data collection strategy, which focuses instead of kind of streaming content, stuff that might appear in a random sample of tweets, like we've been using here to identify these hashtags, or probably random sample of tweets. We actually don't know if the generation process is random, but that's another issue. We can also use the user as the point of sampling. If we have a list of known users, then we can collect for each user's approximately the last 3,200 tweets of that user. And from that, we can then begin to populate what you might call time series data. But if your goal is to get all the data on Twitter for one hashtag or set of terms, even Twitter itself might not have that data depending on the scale of your request and the difficult nature of sampling from the very large data sets that are necessary to create that data. So for the most part, most people using Twitter are either prospectively collecting data from Twitter, meaning each day they write some code that looks for some terms that they care about and then populating a database. That data is being drawn from a small microsample of all Twitter, so you're even then not insured of getting all the data. Or people are starting out with a list of Twitter users who they care to follow. And you can imagine either having a list, we're going to work with data from US senators, but you could also imagine combining something like respondent-driven sampling to use a given seed set of users, find all the people they follow, and then create some type of population that you care about. However you were to do it, you would then be finding users and collecting their retrospective tweets. You cannot get retrospective network data, meaning if you would like to know whether Matt followed Duncan Watts 2 weeks ago, you can't know that. You can know whether Matt is following Duncan Watts now, but not 2 weeks ago. So if you wanted that type of dynamic social network data, you would need to collect it prospectively each day. Okay, so with those caveats in mind, we can, and with the earlier caveat about the relatively low frequency of Twitter users who share their geolocation, we can use tools in our tweet, which I'm illustrating here, that can plot the latitude and longitude of each tweet in about Korea, including 2 people who are apparently on the Great Lakes or on a boat. Why they were tweeting about Korea, I cannot tell you. But I'm just demoing some of the functionality of the rtweet package. I'm going to go a little bit quicker than I'd like for the next few slides, only because I really want to get to the discussion of apps and bots. Let's say we have an individual user. As I just mentioned, we want to collect tweets by that users. We can use the get_timelines function from the rtweet package to do that. This is what that looks like. We're here searching for Bernie Sanders tweets. We're getting 5 tweets from Bernie Sanders' timeline. The timeline is his list of tweets. And we're visualizing in this next slide those 5 tweets. We can also get general information from the profile of a given user using the lookup users function. This will give us things like the biography, the About Me section of a user's Twitter page, maybe their location, the number of followers they have, the number of tweets they've produced, the number of tweets they've favorited or liked, and so on and so forth. And so here we see that our tweet has nicely created a data frame for us called Sanders Twitter profile. And from there we have different fields that we could index. Here we're looking at the description. Here we're looking at Sanders' location, the number of followers, and so on. We can also make calls to get the favorites of any given user. So here we're asking for the last 5 favorited tweets by Bernie Sanders. And then we've created a data frame called Sanders Favorites. And we are using the text frame of that. We're visualizing the text frame from that data frame here. And these are, at the time I created these slides, the last 5 tweets by Bernie Sanders. I want to point out this funny looking text right here, which we're going to learn tomorrow is the way that our tweet has decided to represent an emoji in our tweets. And that's going to create some headaches for us tomorrow, as I'll describe when we get into text analysis. Many of you are interested in social network analysis. I mentioned one of the great features of digital trace data is that they capture social relationships. And Twitter, perhaps more than any other public resource, allows us to collect massive amounts of network data, which we can do all sorts of interesting things with. So here's the code to extract the names of the people who follow Bernie Sanders. We've created an object called Sanders Follows. We can then browse that. We can also get the friends of Bernie Sanders, meaning the names of the people who Bernie Sanders follows, using the get_friends function. I mentioned earlier that many APIs do not tell you what the rate limits are. Twitter is an exception. Twitter has a useful API call that can be made to obtain your personal rate limits for different types of requests. And Twitter tells you exactly how many requests you can make within a certain time frame for different types of data. So you're allowed to get some types of data more often than others. If you run this function, rate_limit, it will produce a data frame that will allow you to see what your current rate limits are. So for example, these are different types of requests you can make from the Twitter API. You could ask for, if you knew about a Twitter list, a list of users who have been aggregated by another user for some purpose, and you wanted to get the names of those users, you can get 900 of those every 15 minutes. But on the other hand, if you wanted to know how many people are subscribing to that list, you can only get the names of 15 people every 15 minutes. And these are dynamic fields that will change as you make requests and may change according to your lifetime behavior. And also, importantly, you should know that this rate limit request is also rate limited. So meaning if you were to make this call every single time you pass through a loop, you would probably unintentionally trigger rate limiting. So you can either write a function that looks up your rate limits periodically and then pauses your code using something like the sys.sleep function in R to wait and collect the appropriate amount of data within the appropriate amount of time. Or you can just generically kind of identify what type of data you're looking for, like maybe timelines is a common thing. We just got Bernie Sanders timeline, and we might want to know how many tweets we can collect in a certain time frame, and then we may simply pause for 1 second at the end of our loop, and knowing that that will roughly yield near the appropriate number of API calls. There are a number of other handy functions. This one gets trends for particular locations. So what's trending in New York, you can use that. We see all this junk. And our tweet, this is one of my favorites, can also post a tweet via your account. So however you're authenticated, if you were to run this code, this message, I love APIs, would appear in the Twitter timeline of the user who authenticated the app. So if you run this code and you're logged in as you, this will tweet as you to write I love APIs. And as I've noted up here, this is a useful function if you are building a bot. In my own work with bots, we've had to write our own custom code, but if you have a fairly primitive bot, this may be fine to get you what you need. So obviously, as we did with screen scraping, we very often want to iterate across a large population of hashtags or users or network structures, and we simply do that by wrapping all our API calls that we're making via the rtweet package within a loop. So here, for example, we're reading in a list of elected officials that I've got posted on my GitHub, and we're using the read CSV function to create a data frame called elected officials. This has the name of elected officials and their screen name or Twitter handle. One thing you should know about Twitter is that Twitter users can change their Twitter handle, but not their user ID. So if you are following people over time, you should use their user ID and not their Twitter handle, because people do occasionally change their Twitter handle. So one of the other fields you can see in the databases you produce through our tweet will be a user ID field, and that can be useful for finding, making sure you've got the right person, especially if you're in the business of linking data across platforms. Another thing to tell you is that each individual tweet has its own ID. It's called a status ID. And I mentioned earlier that it's hard to get historical data on Twitter, but it's possible, given a list of status IDs, to do what's known as hydrating tweets, meaning going back and populating a database with other mentions or interactions of that tweet, or a list of other objects of interest that you might want to scrape. So there are a variety of packages, especially in Python, but also in R, that would allow you to hydrate tweets in that manner. But again, very often we're working from a known population. Here we're looking at elected officials. And what we're going to do in our code is simply go through each user and put in their screen name. Again, probably it would be better to put in their user ID, but for now we're using their screen name because I think it's just more recognizable to people. We're creating a bin to put the data in that we're creating each time through. This is a blank data frame. That's what we're doing here. And then we're saying for each row of our elected officials data frame, so if you're new to loops, you know that you'll need to know that this is an abstract variable, which is going to assume a different value between this number and this number here. This code, if I were to run it, would produce the number 457, I believe. We need that abstraction so that we can handle data frames of different lengths. But here what we're doing is we're going to change the value of I 457 times for each value between 1 and 457. When we do that, in this line of code, we change the screen name of the elected official that's passed to the getTimeline function, generating a unique database of tweets for that user. Next, we are binding each row of the individual Twitter user's data into our pre-existing data frame. So the first time through the loop, we're actually putting in the first row of tweets. The second time, we're adding and getting it bigger and bigger and bigger. We're pausing here to avoid rate limiting in a relatively hackish manner using this sys.sleep function. We could have gotten fancier with the rate limit function, but we're keeping things simple right now. And lastly, we've printed I at the end of our loop. This is useful if you're new in writing loops. If your code breaks, for example, let's say you've been rate limited, you might like to know when you were rate limited. And if you were rate limited after your 200th call, you'd know that you made too many calls when you reached 200 within the time frame within which your code ran. And you could also write code to tell you when your code started and ended if you wanted to get fancy about it. Or it may be that you have a blank row in your data frame, and when you pass that to the getTimelines function, you got an error, and then you want to know where that is so that you can go and clean up that line of data or understand why it was blank, even better. Okay. So the good news is, even though it can be frustrating to navigate the API documentation and to construct your own API calls, there are many, many R packages now and Python modules that will allow you to create API calls without the tedium of sifting through the R API documentation. So we've got R Google Maps, R Facebook, which now doesn't do much but used to do a lot, and R OpenSci, which is a nice collection of open science resources in the R community that has some nice lists of R packages that work with various APIs. R OpenGov. OpenGov is another large API for political research and legislative research. R Times, which queries the New York Times API. WDI, which queries the World Bank's API, and on and on and on and on. And you'll notice if you've been using and installing packages from CRAN, you may also wish to know that many of the most interesting packages that are new are hosted only on GitHub and have to go through a process of vetting and approval in order to make it onto CRAN. So some of the newest and most adapted stuff might be on GitHub, and it might not yet have gone through the process of review on CRAN, or the author of the package may simply decide just to keep it on GitHub instead of going through the review process, which can be a little arduous. Okay. There are also, finally, APIs that can do your analysis for you. So far in this lecture, we focused on APIs doing things like collecting data, transferring data, but APIs can do analysis on your data. So there's visualization APIs like Plotly. There's image recognition APIs like the Google Image API. So last year, one of the Summer Institute projects passed tweets by elected officials through the Google Image API in order to look at the visual space of politics. There's optical character recognition APIs. There's APIs that run neural nets for you. There's APIs that do all manner of things, and we don't have time to cover them. But just so you know, if you don't know already, APIs do a lot of other things apart from just transfer data. Challenges of working with APIs include the documentation I've already mentioned, the process of credentialing, figuring out rate limiting, and of course just the general frustration that not everything that you might want in a database is available via the API. But when we compare it to screen scraping and the tedium of going through and finding the XPath or the CSS selector and knowing that there are even better packages that parse the data and produce it in a format that's easy for us to analyze, usually I think most people will find that APIs are a superior alternative for social science research. And I started out with a list of from Programmable Web that describes some of the kind of first census of APIs. Here are some other resources that I've collected over the years that are some packages and APIs that I think will be of interest to social scientists. And I want to focus your attention on this last one here, which is a crowdsourced list of APIs that participants in the Summer Institutes over the last 3 years have added to, which is a list of APIs that people think may be of interest to social science research. So if you know of APIs that aren't on here, please add them. If you're looking for some new data sources, please check this out. Quite unfortunately, we now have 10 minutes to get through about an hour of content. So this is a big bummer. I think we are going to need to cut a lot of corners, and I apologize for that, especially for those of you on the live stream. I'm going to direct you to the annotated code for this section, which will go into a lot more detail than I have time to do. But I just want to talk about apps and bots as techniques or tools for trying to overcome some of the weaknesses of digital trace data that we talked about in the beginning. These are some of Matt's and mine: incomplete, inaccessible, non-representative, drifting, algorithmic confounding. They're dirty or unstructured, and sensitive. And I'm going to argue that app-based research allows us, with maybe like a better alternative than just like kind of jettisoning this data. Like we obviously can't just like not look at social media if we want to study health behaviors, right, or electoral processes or politics. So the idea is, how do we integrate them? And I'm going to argue, that as survey response continue to drop, and as many of our most important questions require longitudinal data, relational data, qualitative or text-based data, we need to have a reckoning with these techniques. And we have to remember that the positives, there are fewer positives than weaknesses at this point, but those positives are big positives. So we have to figure out how to keep the good and deal with the bad. And I argue in a lot of my work that we can kind of have our cake and eat it too. We can overcome many, though not all, of the weaknesses of digital trace data by building apps to collect social science data. So back in the Stone Age, about 6 years ago, I was developing what I called at the time social media survey apps. And my idea was that we should try to provide some kind of conventional social science structure for the free-flowing, naturally occurring data that we all want to analyze. And I developed the idea of a social media survey app as a means of both extracting the digital trace data, but then also surveying the people who produce that data about other characteristics that are not observable from the social media data. And an additional advantage, there's a number of advantages of this I'm going to run through, but the principal advantages are filling in the blind spots in our data. We know that it's non-representative, but at least now we can know how it's non-representative if we use a social media survey app to, for example, ask people about their demographics. We create a new contract with the user. We get around a lot of the ethical issues because we can have an informed consent dialogue within the authentication of the app. We can structure our data better. And very often we can ask for additional permission to access data that's not readily or publicly available about the user. So in the case I'm going to show you, we're going to look at an app I built that helped nonprofit organizations optimize their social media outreach. And in return, the app offered them an analysis of how they were doing to their peers. This simultaneously allowed me to collect the text-based data and the public Facebook data that at the time was available, and insights data, which you can think of as kind of Google Analytics. So if you've been to Google Analytics, you can see that you can track the demographics of people who are visiting a page, or maybe how often people are clicking on a page, or maybe the geolocation from which people are clicking on a page. These aggregated data can be then used to further validate things like audience structure and audience interaction with the public post that you can't see, but the owner of the, in this case, public fan page or Facebook fan page can see. So this app that I'm about to share with you both collects the publicly available data, gets a non-public form of Facebook data that includes over 100 metrics that describe various properties of users and their behavior and interaction with the website, and ask them additional survey questions to further fill in the blind spots that they can't get from either the public data or the private data. And so that's basically just what I said there. So the workflow of an app, I mean, this is a very simple template. Typically, there's some kind of user authentication. So just like when we authenticated with Twitter, you agreed to allow the app to transfer your data. If you are surveying a population, maybe you have at the end of your Qualtrics survey or the end of your Google form or whatever you're using for your survey, you ask people to give you permission to access their data. Obviously, you need to carefully prepare the respondent to know what they're sharing, why they're sharing it, who they're sharing it with, how the data is going to be protected and used, and this is an important step. But it's one that can be clearly articulated as juxtaposed with the many arguably less ethical research that's gone on, either with just simply studying the publicly available data, which even though that data is in the public domain, the people who produced it might not know that it was in the public domain and it could be studied, and that raises a particular kind of ethical issue. Or the kind of ethical challenges created by research that occurs without informed consent by experimenting natively within the platforms, like the emotional contagion experiment. This was back when we used the term big data, apologies. But basically, notwithstanding my neologism, we've got user authentication. That then triggers an app collecting some type of data field. Then the user is redirected to a survey, or maybe they do the survey first and then come to the authentication, depending on your workflow. That survey can then get sent to some kind of cloud server where the data is stored. Then the app, if it's going to offer something back to the user, and not all apps need to do this, many people are now paying users to use apps. So large survey firms might pay people $10 to use an app that then shares their data with the research team. But if you make the data yourself, you can create some kind of user-incentivized participation in research. In this case, I was trying to help organ donation groups increase the number of people who are aware of organ donation, and they were very interested in knowing how their particular organization compared to their peers and wanted to learn from the successes of their peers and avoid the negative experiences of their peers. And so this app created an audit by looking at all the population of organizations who participated in the study together and delivered a report about what they're doing well and not well. And it had the mouthful name, the viralgorithm, which is no longer live. But basically, what's going on behind the scenes is calls to the Facebook API, calls to a Google API. Those are getting piped to a cloud server, analyzed, and then in the Stone Ages, we actually emailed a PDF report, but of course now it's much easier to deliver that analysis in more or less real time using something like a Shiny app or perhaps a Flutter app, which I'm going to describe in just one second. The neat thing about this effort, I think, was that we were able to fill in knowledge about issues of representativeness. So earlier I was asked a few questions about what you do when you don't know how representative the data is. We're able to actually benchmark this against a census of nonprofit organizations and look at selection issues and do it, and also combine this with a kind of respondent-driven sampling. So if you build an app that's successful and people share it with their peers, then you can have a tandem sampling approach, which includes both respondent-driven sampling and some form of stratified sampling. Now, as Matt's research would show, you need to be careful and know which types of respondent-driven sampling create bias, but one can also make an argument that this scales well to difficult-to-reach populations. The interesting thing is in this first of its kind app, we got a 40% response rate, which is pretty high, I thought, even though we're studying organizational populations, which have typically higher levels of response rates to surveys, and very minimal evidence of selection bias according to these observables that I don't have time to describe, but are in a paper that are linked in the slides. So one of the challenges of building apps for social science research, For a long time, it required significant coding skills that kind of transcend a lot of the base skills that many of you may now have in R or Python. Skills in creating web pages, dealing with the aesthetics, CSS, cloud computing, reactive programming, which is challenging for many social scientists. There's a competitive environment for attention, so why should someone use your app and not some other app? That's become increasingly a problem. And there's pervasive concerns about data sharing and privacy. So now there's the stigma of Cambridge Analytica, and it's a different, people have some idea of what might happen when they share their data. Although my conversations with major survey firms who are using these apps suggest that these have minimal effect on people's willingness to share data. But that's an empirical question that we need more research on. Compelling incentives are hard to identify. What can your app give that someone doesn't already have or need? And building those incentives into your app can be non-trivial in terms of the coding involved. But again, if you can afford it, and one of your group projects may well be able to afford it, here at SICSS, you can pay people to use an app. So you've got a few options for building apps. One is Shiny. Shiny is an interactive platform within RStudio, hosted and maintained by RStudio, that allows one to create interactive HTML, JavaScript pages that allow users to interact with a web page. It's a relatively new tool. It's not so new anymore. An example, I'm disconnected from the internet, quite unfortunately, but if I were able to mouse over this chart, you'd see that I can interact with this data from Google Charts, and pull sliders and move the data around. It's useful for kind of data visualization, but as I'll show you in just a second, when we get inside the guts of the Shiny app, we can embed calls to APIs, and we can ask for user authentication, and we can use that to create an authentication dialog within the Shiny app, and also to send data to a database, like a Google database, and so on and so forth. And there's examples of Shiny apps that, for example, collect Twitter data, look at mentions of Twitter themes over time, and so on and so forth. There are 3 components of a Shiny app, the global script, the server script, and the UI script. The global script defines objects that are going to be used universally across all of the code, so things like variables you might want to track in your code. Sorry I'm rushing through this, but we're running out of time. The server is actually what's the guts of the code that's doing the analysis that gets displayed in the web page that you're building. So if you were making API calls that you were then going to visualize, this would be a set of instructions about how to collect that data. The UI is the user interface script, and that explains the aesthetics, what the user is going to see in their browser. And so basically, a Shiny app includes these 3 components. It used to be you needed 3 separate files. Now they can all be in one file. And you can build a pretty serviceable app. The neat thing about Shiny is that there's a large and vibrant community of people developing Shiny apps, many of whom share their code. And this is an open source community with a lot of templates that might inspire you to work from here. By the way, I mentioned references to work on this and on sampling issues related to using apps for social science research. Those are all, I think I mentioned they're in the slides, they're actually in the markdown document or the annotated code document. You can see them there. You may say, well, I've never linked to a cloud server before. How do I do that? Well, lo and behold, there's the Google Drive package, or the Google Sheets package, which will allow you to populate a Google Sheet, assuming you've authenticated with data. So, the neat thing is, at the outset I said, well, you need significant programming experience to do all this, but now you don't need to know how to spin up a cloud server and how to populate that and authenticate that in order to push data there. You just need to read the vignette on the Google Drive package and embed it within the server script in your Shiny app. I'm not saying any of you might do this tomorrow if you've never developed Shiny before, but it's easier than you might think. The ability, we're really getting at the point where people are building tools that make tools. And that goes for machine learning as well. A lot of the interfaces and APIs for working with, for example, neural nets in R work through R packages like Keras, which are making API calls that allow us to spin up and define and run those apps. So we are, I think, unfortunately, I've got the old slides up here. Sorry. Let me just see if I can quickly navigate to my new slides here. Apologies for that. The last thing I wanted to talk about, because I'm now the only thing that stands between you and lunch, or dinner if you are in Oxford and you're very hungry because of our fire drill. Just going to quickly see if I can pull up the right data here. I think we have two HTML. Yeah, this is the old one, sorry. Here's the new one. Okay. So finally, I'm just going to briefly talk about bots. Sorry, I also want to talk about one more thing before we talk about bots, and that is another really neat new tool. Just like Shiny is trying to make it easier for people to build apps, Google has produced a really neat tool called Flutter. So Flutter is a new development tool that can simultaneously build apps in iOS, in Android, and a web-based version. So basically, there's one development environment. Oh God, no, 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 no. So you'll see the development environment on the left. This is a code development environment called vCode. But the really neat thing is you can run simulators of mobile devices as you code. So as you tweak your code, you're actually going to see aesthetically how it appears in mobile. So if you have interest in developing mobile apps or that simultaneously scale across different operating systems, and even eventually Flutter is working on, or Google is working on extending this to web, you will see a really neat opportunity to avoid building separate software for iOS and Android and so on and so forth. And combined with many of the other tools we've talked about, you can build some pretty neat apps now. We are currently developing a Flutter app in the Polarization Lab, and we're hoping to open source that as soon as possible, probably by this fall. So if you're interested in that, let me know. I can turn you on to some resources. The short story is you need a lot of it. You need getting a Flutter workflow set up might take about an hour, but that's not because it's hard, it's just you're downloading a lot of dependencies, and it's very well documented online. I think I have a link somewhere in the slides. If we get the right ones linked on the schedule, we can look at that. Okay, we're 5 minutes over. Bots is one of my favorite topics, so this is just gonna be a whirlwind tour. Why bots? Well, first I wanna give a shout out to one of our current participants who did some of the really creative and interesting, was part of the first wave of bot-based research, I think. This is a paper that Kevin Munger wrote that recently appeared in Political Behavior, Tweetment Effects on the Tweeted, Experimentally Reducing Racist Harassment. And here in this really neat paper, Kevin developed a avatar that was either black or white that responded to racist commentary and was able to show that when white people censored the racist language, there was a reduction in racist language that did not occur when black avatars censored the racist language. As a really neat, the paper does a number of nice things, and I encourage you to check it out. But for me, I think it's really neat in developing kind of a new model of research. Bots can do things, and many other people, many of us are using bots in, say, network experiments or network games, and people like Nicholas Christakis or Damon Centaur, or in the Polarization Lab, we've done some Wisdom of Crowds style bot-based studies where you inject a bot into a debate or into some kind of multiplayer game. But for field experiments, it's really neat because you can actually send something out into the world. Now, this raises huge ethical issues. And in a recent study in the Polarization Lab that just came out a while ago in PNAS, we built bots that exposed Republican and Democrat respondents to a large survey. We offered them financial incentives in our treatment conditions to follow bots that retweeted messages from elected officials from the opposing political party in order to study what happens when you kind of experimentally disrupt people's social media echo chambers. And this is the study I was mentioning at the outset today, where we linked the survey data to the Twitter data. And of course, we have all the rich data of interactions between the bots and who retweeted what, and mountains and mountains of data on text. We also collected daily slices of the network to try to see when and how these things scale. This can all be linked and studied in a number of ways, and our paper takes a first cut at that, showing that exposure to opposing views actually increases partisanship, at least as defined through substantive issue positions on a liberal, kind of standard liberal conservative scale. So how do I build a bot? Earlier I mentioned that there is a native function within our tweet that allows you to post a message. So if you've created a bot account, and this is a little harder than it used to be with Twitter, Tom has some recent experience here if anybody's interested in building bots, and maybe Kevin, I think, has a new paper you might be able to share more with us about that. Twitter has cracked down on bots, and that has complicated bot-based research. But basically, you create an account, and then you can host some R code, often on a cloud server, that runs in a repeated fashion and intervenes or posts something in a targeted way. And here's, for example, a bot that would randomly retweet the last 50 tweets that mention computational social science, and then retweets one of them every 60 minutes. Now, this is trivial. This is not going to do anything for social science research, but you can imagine once we've carefully identified a population of racist tweets or of elected officials who are retweeting content that we want to expose people to, we can begin to intervene based on rules we defined elsewhere in the code. So this is really just like a template of something that could be much more complicated. This is the workflow from Kevin's paper that we don't have time to go through in detail. I just want to give you one last tool in your toolkit for hosting a bot. Many of you may not know that you can run an instance of RStudio or Jupyter Notebooks or whatever you like to use on a cloud server such as Amazon Web Services, that you can also use Google, Microsoft now. There's a tutorial linked here that I use in one of my graduate seminars that tells you how to get a workflow of RStudio working in the cloud. And essentially, this allows you to either put a machine up there and let it run a bot or something like that, or to open, say, 20 instances of RStudio at the same time and run 20 different types of text analysis, or perhaps most usefully, purchasing time on a really large computer if you have some heavy number crunching task that could save you hours or days. So if you don't know how to run an instance of RStudio in the cloud, I would check this out regardless of whether you want to build a bot. They're also useful for storing data. So Amazon Web Services both has an elastic compute cloud where you might run your instance of RStudio. It also has a server system called S2 where you might serve or push your data collected by an app or a bot or whatever else you're making. Okay, so yeah, there's ethical issues in bot-based research, right? Mainly, chiefly, and I think this came up. I think I overheard a group discussion about this. If people are interacting with a bot, are you under an obligation to tell them they're interacting with a bot? In our case, we did tell them that they were going to interact with a bot. We didn't tell them what kind of bot or what the bot would retweet. Other study designs will have a bot in a model and then later debrief people telling them that they interact with a bot. But these are some of the genre of ethical issues that come up. Also, in principle, one thing that terrified me, and one thing that inspired me when we were having discussion of ethics, we had Gary King here 2 years ago, who's, for those of you who don't know, is like a leading computational social science, political scientist. And he really shared a lot of vivid details about ethical trials and tribulations in his research, when he was like, well, maybe it was unethical to roll out healthcare to one part of Mexico, but not another, and it was illuminating to me that we should all share these kind of ethical dilemmas that we come through. So when we were running our bot study where we exposed people to information from opinion leaders from the opposing political party, we didn't know if it could retweet misinformation or trolls or something like that. So I actually had a phone notification every single time that our bot tweeted so that I could manually review in the most depressing month of my life the content that was going out. But these are the kind of safeguards that I think, mountains beyond mountains that we're all trying to work out. And I was very nervous during that entire period that I might somehow mess things up even more. And here's another example of why we need to think carefully as we send bots out into the world to help us do our research. So we're 15 minutes over. Apologies for the lapse in lunch planning. The group exercise for this afternoon, I want to quickly go over for people in the partner sites. It is available on the, it's linked on the slides for on the main schedule. Basically, the idea is to break into small groups by counting off. We're going to do that in another room for folks who are here at Princeton. You're going to work for 15 minutes to identify a research question that you believe can be answered using some of the methods we discussed this morning. Identify a sampling frame to help you answer this research question. For example, if your question is about politics, your sampling frame might be a list of elected officials on Twitter like we used. Use legal screen scraping techniques in order to collect the names of individual accounts, keywords, or topic areas to populate your sample. write code to collect data from each unit of analysis in your sample and evaluate the strengths and weaknesses of the data you've collected using the discussion and the strengths and weaknesses we talked about this morning. And if you get this far, and different groups will complete the exercise or not complete the exercise, outline a hybrid research design. Don't actually build the bot or the app, but have a conversation about how an app or a bot could help you address some of the weaknesses of your study's research design. Now you'll notice that this exercise is a little more open than the one from yesterday, and that's by design. We're trying to incubate group research projects among you, both you here in Princeton and also you everywhere else, and also people across sites or further down the line. So really use this as an opportunity. These are not hard and fast rules. I want you to explore each other as researchers and as scholars. There's only one requirement that I would ask for this study, for this part of the study, which is that within each group, I would ask that the person with the least coding experience write the code. And the idea there is that everyone who has deep domain knowledge will have to vocalize it, which will help them teach, and it will help the person with less coding confidence develop the skills, the concrete skills they need. And of course, remember our principles of generosity, patience, respect, openness, togetherness. It might take time, and you might want to just cut and paste something from your old code, but please remember that other people are also learning around you, and you can learn to teach if you know this stuff already. And if you don't know this stuff already, most of the people at the Institute, broadly defined, are like you. So please insist upon slowing down the workflow. And there will be time in the beginning of next week to have much more extended and elaborated discussions about how to develop and design a group project. And we're assuming at this point that many of your lunchtime conversations or dinner time conversations may morph into broader discussions about group projects. Though, again, we'll do that research speed dating thing at the beginning of next week. Okay, so I don't have time for questions, and I know everybody here is hungry and everybody in Istanbul is sleepy, so we will see you tomorrow, and apologies again for the fire drill and assorted AV mishaps. Thank you. Thanks.